Okay, we will start inviting the members. Welcome, Mr. Montenegro, and please, the members of the front table could join us. Dr. Gassem Asrar, Mr. Mr. Senthold Hassing, Dr. Herman Lotz-Kampen, Dr. Cynthia Rosenzweig, Dr. Anthony Whitbread. Please join us at the front table so we can start with the event, with the opening. The Inter-American Institute for Cooperation on Agriculture, IICA, is honored to host the 7th meeting of the Agricultural Model Intercomparison and Improvement Project, AgMIP 7. We welcome all the participants from so many countries around the world at this plenary session, and we also welcome the panelists, Dr. Gassem Asrar, Dr. Senthold Hassing, Dr. Herman Lotze-Kampen, Dr. Cynthia Rosenzweig, Dr. Anthony Whitbread, and on behalf of IICA, Dr. Diego Montenegro. They will speak about the AgMIP and challenges for agricultural decision support. But first, let us hear some welcome remarks from IICA's Director of Management and Regional Integration, Dr. Montenegro. Please, Don Diego.
Thank you. Good morning. Good morning again. Buenos días a todos, a todas. Distinguished members of the head table, distinguished participants, the Inter-American Institute for Cooperation in Agriculture is very pleased to welcome you all to its headquarters, to the House of Agriculture in the Americas. And welcome to beautiful Costa Rica. Bienvenidos. IICA opens its doors and arms to receive you all representatives from 5 continents in this high-level and relevant global workshop entitled Pathways to Agricultural Transformation. Indeed, world agriculture is facing new challenges. Climate change is creating shifts, new contexts, new challenges, and increasing uncertainty in food security systems. Many of you, as researchers and public sector representatives, and IICA as a hemispheric specialized technical cooperation agency, we all share the same challenges. Therefore, there is an urgent need to integrate our different capacities and experiences. The partnership between AgMIP and IICA provides an excellent opportunity for synergistic exchange in our cultural systems and outcomes. We have a very exciting program ahead of us. It offers a mix of innovative research results as well as sessions to organize our cultural modeling and research applications. IICA is very proud to host in its headquarters so many crucial and interesting discussions and the most brilliant minds thinking about the future of agriculture. We are sure that this collaboration will help us to provide improved support to our countries and more especially to our farming families. So thank you. Thank you very much and welcome again.
Thank you, Don Diego. Now we will invite the members of the head table to join us at this first row so you can appreciate the presentation on the screen that Mr. Montenegro will be able to present now. Mr. Montenegro, please come to the podium to present about the challenges from the Latin American perspective, please.
Hello again. Good morning again. I'd like to excuse our Director General, Manuel Otero, who had to attend some unexpected meeting early this morning, and he will be joining us during the day. This short presentation is divided in 4 main sections. The first part deals with a short description of what ICA does and how we are organized. The second part has to do with some relevant facts about agriculture in Latin America and the Caribbean and some of its major challenges. Then we'll talk about the role of ICA as an articulating agent in the region, between countries, between sectors, and between topics. And then finally, we'll talk about some opportunities for collaboration. Having said that, let's start with a simple description of what ICA does and what ICA is. ICA is the specialized agency for agriculture of the Inter-American system. It supports its member states to achieve sustainable agricultural and rural well-being. It's been founded more than 75 years ago. We can say that we are a young adult institution. We have 35 delegations in each one of our member states. We have installed technical capacity in each one of those offices. And whenever we don't have it, we find ways to identify in our large number of consultants a way to identify that specific support that is needed to provide our technical cooperation. Our highest governing body is the Inter-American Board of Agriculture, which is composed of our 34 ministers of agriculture. We're in the process of increasing the number of ministers, not only from the agricultural sector, but also from other sectors, so we promote this idea of a more integral approach of agriculture, especially ministers from the environment, ministers from public investment, and so on and so forth. We have an important network of specialists across the Americas. And when I say the Americas, I focus specifically on Latin America and the Caribbean. As I mentioned, we have quite a large network of specialists and consultants that can provide technical cooperation if needed. We work under the premise that if we don't have it, we find a way to find it. We have a wide range of partnerships. We work with the private sector, we work with the academic sector, we work with the private and public sector, with NGOs, with the civil society, and we work mainly through agreements that deal at a national level and also deal at a regional level. I should mention that ICA organizes its technical cooperation efforts in 5 main regions that are associated and linked to the 5 regional integration mechanisms, something that we had a chance to discuss yesterday with the board and with our Director General. We have offices in the Southern Cone, in our 5 member states, 5 in the Andean region, 7 in Central America, 14 in the Caribbean, and 3 offices in Mexico, the United States, and Canada. We have 18 observer countries that range from Germany to Russia to Portugal, Romania, Austria, France, and several others. And recently, Spain joined us as an associate country. We have an office in Madrid that acts as a link with the European Union. We are currently in the process of putting together our medium-term plan, which is our main planning instrument of our technical cooperation. This new administration with Dr. Manuel Otero's guidance is working to put together a new innovative approach towards technical cooperation through a medium-term plan from 2018 to 2022. And it is in the framework of what we have as a 10-year strategic plan that has identified already 4 main strategic objectives. Those have to do with the improvement of productivity and competitiveness for the agricultural sector, the improvement of capacities to mitigate and adapt climate change, the strengthening of agriculture to contribute to the development of the rural areas, and finally, the improvement of agriculture as a contribution to food security. Now, we are working currently to put together this new medium-term plan that will come into effect July of this year, when one of our governing bodies meets here in this same space to approve the medium-term plan, which will be closely associated with 17 sustainable development goals. Allow me to share some key pieces of information that I think are relevant and reflect the importance of agriculture as a generator of income, employment, and food. Agricultural production in the last 10 years has grown as an average of 2.1%, almost similar to other goods and services in GDPs of all our member states, which is a good signal. The value of primary production, and I specify primary production, is $2,075 billion, which represents an average of about 5.6% of the GDP of our member states. I have to say that we have member states that have agriculture playing a much important role in the GDPs. I can mention Guyana, close to 40%. I can mention Bolivia or Peru, close to 18 or 20%, and so on and so forth. Besides being a provider of food, the agricultural sector generates close to 16% of total labor force. And here I'm talking about direct employment. And we have an estimated figure of about 60 million persons that are involved in family farming in Latin America and the Caribbean. We can talk about definitions about family farming, but a great number of families in the rural areas are involved in what we believe or we define as family farming. Let's move to some relevant data about the agricultural sector increased competitiveness and presence in international trade. I think we need to go one before. Yeah. Over 50% of agricultural growth in Latin America in the last 10 years has been due to productivity. As you recall, before this decade, agricultural growth in Latin America and in the Caribbean was very much associated with land clearance to crop production. Now we can say that about 50% of that increased production has to do with productivity, which I believe is a very good indicator. $221 billion of world agri-food exports come from this region, Latin America and the Caribbean, representing about 25% of the total goods and services exported in those countries. Nowadays, close to 37% of all agri-food exports are exported to Asian markets. So we have definitely identified in Latin America Asian markets, obviously associated with a rapid increase of population and the new trends of consumption that are taking place in Asian markets. We have identified three main drivers that we, or perhaps I should say trends, that would contribute to Latin America playing a leading role in the global food supply. First of all, we already have mentioned it, the rapid population with enormous numbers of rural families migrating to urban areas. We have estimates, there are estimates to talk about the fact that by 2050, close to 80% of the total world population will be living in cities. So we have there a very important trend that we need to address in order to retain young farmers, young family members in the rural areas through different mechanisms that we are studying. Intermediate cities are one of the mechanisms that we are identified for that, to try to increase that rapid migration of young people to urban areas. An increasing middle class that is increasing incomes and introducing new consumer trends, more sophisticated demand. Greater demand on certain particular products, talking about meat, talking about cereals. All of them have the characteristics of being water-intensive products, which represent opportunities for the agriculture in Latin America and in the Caribbean. A sustainable use of that 35% resource of fresh water, and about 20% or 28% of the land worldwide that could be used for sustainable crop expansion in Latin America and the Caribbean. The challenge indeed is to produce more food, safer food, in less land with less water. So this is the challenge, and this is where we all should be striving for. Please. Despite Latin Americans' great potential, it also faces greater challenges. We have extreme events, increasing frequent and more intense natural disasters. About 306 million hectares in Latin America have been affected by human-induced soil degradation. In the Caribbean, that percentage is about 38%. In Central America, it's close to 50%. And in South America, close to 20%. The Andean region, Mexico, Chile, Argentina, and the dry corridor in Central America are experiencing currently high levels of water stress for agriculture. An important piece of information is that even though we've were able to deliver good results through adequate public policies, still 46% of rural population is still living in poverty. 42.5 million persons are undernourished in Latin America, where 25% of them are population that suffer from obesity. And a very alarming piece of information is that there are estimates that say that 17 million climate migrants will be abandoning their countries due to the effect of climate change. We have been addressing some very touching issues of entire families, entire countries, entire communities in the Pacific Islands looking for places to live. ICA published 2 studies recently that showed how countries committed to climate change international agreements, the so-called national determined contributions. Here are some results that I'd like to share with you in this meeting because I find them very relevant in terms of the types of alliances that we can put together in the future, identifying countries that have shown some commitments based on the on international agreements. 30 countries have chosen to develop agreements and commitments to work in sustainable agriculture. 31 countries in forestry, 16 in livestock. And an interesting number of countries have chosen specific topics to work in. 22 countries in ecosystem-based adaptation. 25 in forestry management and conservation. 23 countries in water resource management. 17 in management, sustainable management practices. And 17 countries in early warning systems. So these are definitely opportunities that have been identified in specific countries where we find opportunities for joint actions, both in public policies, in specific projects and programs that we could all identify. ICA's new medium-term plan puts a lot of emphasis on the role of ICA as a platform, as a bridge between countries, between topics, between organizations, between the relationship of science and politics, between public and private sectors and with civil society. So we are working in this new medium-term plan to make sure that we develop instruments, programs, and mechanisms by which ICA can better act as a platform, as a network of different experiences and shared knowledge. So far, we believe that we have the capacities, we have the infrastructure, and we have the drive to play that role in the following years. Yesterday we briefly discussed about potential ways in which we could cooperate. Both institutions, AgMIP and ICA, share many elements that could be very useful in the development of agreements in the future. There's definitely lots of elements in which we can complement each other. So these are just a few of the features of both institutions that could lead us into a winning partnership. Having said that, I welcome you again, and I thank you for allowing me to provide you with some of these figures and some of this information that could be useful for discussions in the different working groups throughout this very important event. Thank you very much again, and welcome.
Agradecemos al señor Montenegro por su presentación y continuamos con la 7ª edición de AgMIP. Ahora llamamos al podio al señor John Antle, quien será el moderador de esta sesión plenaria. Gracias y tengan todos muy buenos días. En primer lugar, deseo agradecer a Diego y a su equipo por hacer un excelente trabajo y por darnos la oportunidad de reunirnos acá para forjar esta nueva alianza que usted describió, Diego. Solo quería decir en nombre del grupo directivo de AgMIP que estamos muy agradecidos con todos ustedes y les damos la bienvenida a esta reunión. Es una tradición en AgMIP que una de las primeras cosas que hagamos antes de hacer presentaciones más formales y continuemos con el resto del taller, que nos conozcamos mejor. Y algo que hemos venido diciendo durante mucho tiempo es que AgMIP es como una familia. Así que algo que yo quiero hacer es darle la bienvenida a todos los que son nuevos a la familia AgMIP. Entonces, quiero pedirle a todos que se pongan de pie y que levanten la mano. No, mejor se ponen de pie. Desafortunadamente, ahora somos muy numerosos aquí, así que no puedo pedirles que se presenten individualmente, pero quiero pedirle a todos los que están asistiendo a uno de los talleres de AgMIP por primera vez que se pongan de pie para que podamos ver las caras nuevas, a nuestros nuevos amigos. Es muy impresionante. Qué bueno. Es como la mitad de los participantes. Bueno, entonces, por deducción, me imagino que el resto no es nuevo para AgMIP. AgMIP tiene que ver con la colaboración. Sin embargo, a veces tenemos que dividirnos en grupos e identificarnos en términos de las disciplinas que practicamos y la región de donde provenimos. Así que para darles algo de información general para los nuevos de AgMIP, inicialmente nosotros estábamos divididos en 4 equipos. Siempre seguimos utilizando ese sombrero, aunque de diferente color dependiendo del equipo. Ya no tenemos sombreros para esta reunión, pero quiero ver qué es lo que tenemos acá muy rápidamente. ¿Quiénes se identifican como expertos en clima? Se ponen de pie, por favor. Muy bien, excelente. Discúlpeme por unir a cultivo y ganadería, pero eso es lo que vamos a hacer aquí. Los que sean especialistas en estas áreas, modeladores, el lado biofísico de nuestra labor. Hay muchos aquí. Qué bueno. El tercer equipo o grupo, pero serían los economistas. Por favor, todos los economistas mundiales, regionales, que de alguna manera tengan que ver con economía. Bien, qué bueno. En la reunión anterior teníamos más economistas, sí. No, pero creo que tuvimos una reunión hace poco donde asistieron y los especialistas en datos, TI, necesitamos más de ustedes. Esto demuestra que ustedes son tan poderosos y tan universales que no necesitan más compañeros. Y los modeladores de cultivos, quién sabe. Los economistas están detrás de los DTI. Perdón, tengo que avanzar. Ahora hagámoslo por región. En este momento quiero tener alguna idea de esta región, por ejemplo, de Centroamérica.
As from the Central American region. I know you're here, please. Okay, great, great. How about South America? South America. Okay, yeah. Very good crew. Okay, how about North America? Wow. Wow, I didn't realize we had that many North Americans. Great. Okay, East Asia. East Asia, East Asia. Wow. How about South Asia? Or sorry, well, now I have okay, Southeast Asia, and we'll throw Australia in too. What the heck? All right, great. And how about Africa? Okay. Okay, from those last 2 groups, we know the people who are really jet lagged. Not to mention, last but least, how about Europe? Wow, okay. Very good, okay. Thanks, everybody, that's great, welcome. Well, so now we have a few quick slides we wanted to take a look at. Yeah, so what we'd like to do also, just as by way of introduction, particularly for those of you who are new to AgMIP, but also because AgMIP is changing and evolving, and we just wanted to say a few words about that, and you'll hear more about that momentarily. But we just wanted to introduce all the members of our just recently reconfigured AgMIP Steering Council, and we'll be hearing from Gassam Asrar very shortly, and wanted to introduce Jean-Francois Susanna as the other co-chair of the Steering Council, and here are all the other members, many of whom are here and will be participating in the sessions and getting to know you as we go through the week. Oh yeah, right. Thank you, Cynthia, for that prompt. Could they all stand up? Just so you can know who they are, get a little bit of a... Thank you. Those are the ones who are here. And of course, we have some who weren't able to be here as well. Next slide, please. And this is also we have a newly reconfigured AgMIP Executive Committee that is comprised of these folks here. Can you guys, I guess we'll have you stand up too again, what the heck. And an important point here that we just wanted to mention is that we've really, AgMIP started out about 8 years ago, a group of people who had an idea. It's grown into something way beyond our original expectations. And so we have evolved the way we're organizing ourselves. And so in this past year, we've really moved to this leadership structure, which is larger, more geographically diverse. We'd like it to be more diverse in other ways as well. And we hope to move that way in the future. And we also have a rotation now where people are appointed for a certain period of time and then other people will move in. So we're really evolving to what we hope is a much more, a system where we can encourage those of you who have been in AgMIP and are joining AgMIP to move up and join and participate in the leadership as actively as you'd like to. And then finally, one more slide, I would like to just then introduce Ghassem Asrar, who's one of our steering committee council co-chairs. Ghassem is the director of the Joint Chains Research Institute of the Pacific Northwest National Laboratory, hosted by the University of Maryland. Ghassem, that's quite the mouthful there, isn't it? He earned his degrees in civil engineering, environmental physics from Michigan State, and widely published and real expert in the Earth system science area. And we're really have just enjoyed a lot having Ghassem as one of our co-chairs and welcome him to give us a presentation about challenges from the global perspective. Thanks, Ghassem.
Good morning. Thank you very much, John, for the introduction. Allow me to also take this opportunity to thank our hosts for your great hospitality, welcoming us to your beautiful country. And really pleased to see such a great show of participation. Welcome to the entire AgMIP family. I have had the pleasure of participating in these 3 of the last AgMIP meetings, and I'm really impressed to see how the diversity of disciplines and topics of interest and regional representations are continuing to grow. And that's given that AgMIP is a totally voluntary organization, that bodes well for the leadership, that the way that you set your science priorities and activities are so appealing to the community that they vote with their feet because they're totally self-supportive. And clearly, my understanding of the role that AgMIP is playing is one of enabling the scientists who work in this very important field of science who have a problem that they cannot tackle individually or by their organization. They join forces with the leading experts around the world to solve those problems. So that is the spirit of collaboration and cooperation. And of course, I'm so grateful to the previous speaker, Dr. Montenegro, who really set the stage very nicely, because I thought I had a daunting challenge of talking about all these global challenges, the complexities associated with them. And we already have a big and complex mandate of more or less supporting or creating a food secure world. And then in the backdrop, all of these other multinational commitments and agreements are emerging. And of course, the nations who commit to or participatory or signing these agreements have to deal with these multi-dimensional challenges of meeting their food security objectives. And as Diego articulated very clearly, how to also fulfill these other obligations and other commitments. It just that balancing act of preserving what they have, fulfilling the needs of the present generations, and sort of setting the stage for the next generation is a challenge and opportunity for us. As clearly, we cannot solve it all, but that's why my subtitle states is that the role of agricultural research in this very rapidly evolving landscape. And I chose to frame it in the context of how science and technology, a la AgMIP type communities, can really help the nations, the regions around the world to fulfill these multiple obligations. And clearly you saw that, again, by examples and statistics given by Diego, that these multinational agreements make specific reference to the land use and the role that land has to play to meeting their obligations to Paris Agreement, as well as fulfilling their sustainable development goals. Independent of what Diego stated, I also went back and looked at, my data might be a bit old, the total number of countries who are signatory to the Paris Agreement. How many of them have some notion of using land and land-related activities to fulfill their obligations? There are roughly, at that time, the data is a bit old, is 120 out of 160 countries depend on the land to manage their carbon footprint. This is the same land that we use for food production, and then, of course, the land that supports other species, the Convention on Biodiversity, and so on and so forth. So these multiple agreements and commitments have to be balanced in order to really be able to achieve this. So that's where the science comes in. This is where organizations like AgMIP come in. And now, albeit for example, it was a bit disappointing not to see specific reference to agriculture in the Paris Agreement. However, it is implied that clearly, agriculture and agricultural sustainability for us, and of course, a challenge. How do we conduct our science? How do we develop assessments and outlooks of the future that, on one hand, identify sustainable pathways for food production, food distribution and delivery, and on the other hand, fulfilling our obligation to these commitments. And then, of course, this figure was presented earlier, and I just thought of highlighting the connectivity among some of these SDGs. If you only apply the filter of climate to the Sustainable Development Goal, that quickly identifies how this challenge of food production, secure food world would imply in terms of fulfilling the Sustainable Development Goals. And this is illustrated by one of my co-authors. We wrote an article actually leading to Paris negotiations, and we highlighted the need for paying attention to sustainability goals in the context of fulfilling the NDCs. And we said that depending on which goals and objectives you set, you really have a multi-dimensional, sectorial problem or issue to contend with. And clearly, sometimes these objectives are complementary, and sometimes they're competing with each other. Again, this is where the science can really help identify the pathways that could potentially maximize those synergies and perhaps minimize the competitions as much as we can. And, I thought of giving two examples. We go back, the next slide, the one right after this. This one. And I was looking at some of the assessments that the development organizations such as World Bank is doing for some of the countries, such as Bangladesh. It was clearly, again, another data point added to what Diego presented for Latin America and Caribbean. For the country of Bangladesh, since 2000, year 2000, agriculture has been the leading contributor to Bangladesh's success in reducing poverty. The biggest challenge that they're worried about now, both short-term climate variability and long-term climate change, poses a risk to this successful effort. And they see, like the stats that Diego presented, right now Bangladesh roughly enjoys having 3% of its GDP to be contributed by agricultural sector. But the other challenge that they also flagged for Bangladesh is, on top of the climate, the sea level rise that is posing significant risk to the arable land that basically are in the deltaic regions that are subject to the intrusion of saline water. And then, of course, they looked at the number of major cyclones or hurricanes that affected the agriculture system in Bangladesh, and they tried to quantify what was the impact of that. In those 2 years, they roughly estimated that this amounted to 2 million metric tons of rice that could feed 10 million people in that country. And they said the best thing that these development organizations can do with the aid of scientific organizations like AgMIP to do a holistic assessment of the agricultural systems in Bangladesh by accounting for these multiple stressors and helping develop smart agricultural pathways and outlooks that gives them some possibilities of maintaining this sustainable pathway in their agriculture. And as a result, they're requiring any development plan that is submitted to these development agencies for assistance to be provided to Bangladesh to have these type of analysis done as part of those proposals, those requests. So the point I'm making is that this notion of complexity that I was presenting earlier on is really translating to the specific investments that organizations are making in agricultural system in these countries. The next, we went all the way back to the beginning. Maybe you should probably drive. And this is, you can go to the next slide, please. And the next example that I would like to share with you is what I just described to you in terms of what is expected of agriculture is not really specific to the developing nations and regions of the world. It is clearly stated in the expected outcomes of investments that the European Commission is making in agricultural research in Europe. This is put in quotations because it's verbatim. I derive this from the Horizon 2020 document. And they clearly identify that agricultural research should really help deliver effective solutions to ensure that on the farm and landscape climate is smart and resilient system. I added some emphasis to pick up some of the keywords that I'd used in previous slides to highlight that these are really being requested or being expected from the funding agencies that support research in this field of science. They go on to say, unlock and improve viability and replicability of efficient and resilient farming system. Efficiency and resiliency is now being expected to be an integral part of the research that we do, consideration of those. as again, Diego stated, is really the productivity has been superb over the past 50 years because the production has kept pace with the doubling of the population globally. But can we continue to do that in light of the competing demand for land and water? Efficiency must be factored in. Resiliency must be built into the system in order to be able to fulfill the demand of the food demand and create a secure food world. And then, of course, the impact of environment, the role of adaptation and mitigation and development is prominent in these calls as well, something that has been the focus of our research over the past at least 2 decades. But equally important is, of course, this notion of how do we manage these ecosystems in a way that are sustainable for us in terms of production of food, but also accommodating other species, that we depend on them and the services that we derive from this total ecosystem. This holistic look at the systems is really is something that Horizon 2020 is expected to be the outcome of the research that agricultural science is doing in the future. And specifically, these are the current calls for proposals in Horizon 2020 Societal Challenges, a sustainable food security theme that highlights food security with the sustainable agriculture, environment, climate, smart food production and consumption, the whole food system chain, not only production, and of course, the presence of the concerns over the environment and the climate, as well as how we manage these farming systems in a very diverse and rapidly evolving landscape. Similarly, USAID, which its mission is basically development, is paying specific attention to the food security, again, with this holistic look at making sure that it's inclusive, sustainable agricultural systems that support the economic growth and development, paying attention to the resilience of the systems, and making sure that at least those who manage these systems have some information about the potential impact of shocks and disruptive events to these systems, because that translates to the migration and other instabilities. And naturally, they are worried about that. And of course, the food, nutrition, and health, which is a theme that is rapidly emerging within AgMIP, is a major area of interest and focus for them. I could list other organizations and entities who are interested in our research, in your research, and clearly they're looking for this holistic assessment, analysis, a synthesis of the ag systems, and providing some future outlooks about the potential risks of these multiple stressors on the ag system, the food secure world. And that holistic look appears to be something that is really emerging rapidly, again, as was also illustrated in Diego's presentation. And, clearly I'm preaching to the choir because your mission is well stated. This is the mission of AgMIP. Now, among friends, albeit a bit climate centric, I know that we do more than climate. It's something that we need to consider in light of all these competing demands. Prime time for strategic discussion that AgMIP is having. And the activities that you have identified clearly lend itself to producing this type of information at the regional level, at the global level, bringing in the technologies and capabilities to develop these resilient pathways for ag systems, or quantifying the impact of shocks and so on and so forth. So we have the organizational capabilities, we have the focus for our efforts, and a vast number of activities that you do. The question is, how do we integrate the relevant parts and pieces to generate these products at the space and spatial and temporal scale that matters to decision makers, with this notion of considering these multiples or multi-stressors that affect the ag systems. And I couldn't help highlighting an example of what I really mean by this, assessment of the food systems. This is an old example of a publication that came about the time that, that AgMIP was established, but makes the point that if we do the geography of the food, clearly where the food is being produced over the past few decades, and simply by looking at the total production and appropriating a proper portion of that to the humans. I know that AgMIP can do this much, much better because you have it, commodity specific, combination of commodities, you can do that. But this is the very first simple analysis of where food is being produced, what is the demand for food regionally, and the percentages indicate is what percentage of what is being produced totally needed for the region, and the delta from it is what is available for sharing or basically marketing in other parts of the world. That gives us a first order indication that clearly, again, Diego, that's where the Asian market is prime for Latin American market, for sure. Again, this kind of more or less validates, but let's put on top of this very first order analysis, the geography of water availability, the point that you were making earlier on. Again, fortunately, your region at the moment holds roughly 26% of the total fresh water available globally and consumes 6% of it. All needs accommodated. So you are in a oversupply. Look at the Asia where it has the food already is a stressor. Water becomes a major issue as well. So the icons, basically the drops indicates the amount of water available, roughly as percentage of total fresh water available globally. And the icon is representative of the population. So the combination of population, the demand for water, for consumption, for other needs for human. And then now take this and do a regional analysis. Clearly irrigated agriculture has been a major contributor to this rapid, rise of the food production globally. But if you look at it at the regional basis, and based on the demand for water for all uses, not only agriculture, for industry, for energy, for human consumption, and factor in the need for food production, and then take a look forward, you will see that clearly some basins that are doing well today, including California and others, the red indicates is those are the basins that are going to be really stressed because of the competition for water for other uses. Now, if this introduces a shock to the total global agriculture, so what is the potential path forward? So one may say, okay, the irrigated agriculture should make up some of the shortfall. And then if you take this as a representative of the irrigated agricultural basins, clearly you'll see again, there's some shift in geography of food production due to the water availability. And you can put another stressor on top of that. What is the role of droughts and big events that perturbs the production on top of these other stressors? I can leave it up to your imagination. It's just the whole idea, the notion is that if we can take this holistic look at these multiple stressors, that could potentially have additive impacts on the food, geography of the food. How do these combination of these stressors change the first figure that I showed on geography of the food and project it forward for the next, by mid or early mid-century or the latter part of the century? That is the type of outlook I really believe the research investment entities and as well as development organizations are looking forward to have. So again, I really view this as an opportunity for us. We are doing most of the research. Can we find ways and means of putting these bits and pieces together to make the whole greater in sum of what we do, present them in forms of outlooks that provide some notion of how the regions built in some preparedness and resiliency to their food management, food production, food system management, and help them developing the effective policies and practices to take the ebbs and flows out of the system so that we really can help develop a more stable food system. So again, the point I want to leave you with is that we are not suggesting to AgMIP to change direction. This was being discussed among some of my colleagues. It's just about how can we take greater advantage of what AgMIP is doing to meet these increasing, rapidly emerging needs for information in a way that organizations like IACA and other entities can really use that information to help their constituency, to help their stakeholders, and as a result, show greater impact of what AgMIP is doing at the regional level, at the national level, and at the global level. So I thank you very much, and look forward to a very productive week ahead. And again, thank you for your hospitality, and wish you a very successful week.
Thank you, Gassim. That was really a wonderful global perspective, and also thanks, Diego, because that was a wonderful complement to your excellent regional presentation, which really gave us insight into the region, and then Gassim for taking us up to that global perspective. And I can't resist the temptation to just comment that your point about water, is very well taken, and we have had discussions about that. In fact, I failed to ask if people here in the group, are water hydrologists or water modelers. I don't know if anybody here identifies that way. We do have a few. You guys want to? That's excellent. Yeah. So great. Yeah. Thanks. And as Gassim said, that's one of our ongoing challenges is to, this is a hard problem. And again, at the different scales you see in different parts of the world, different issues definitely are arising. Carolyn. Oh, thank you. Yes, I also left out, Carolyn, thank you. Also, I failed to ask the people working in the new food and nutrition and health area to stand up and be recognized. So I know we have some of you here. Yes, great, thanks. I always used to get angry at the AgMIPers for not mentioning livestock. So now I'm guilty of the same thing. So anyway, great. Thank you. Well, and so that's a very nice segue into our next presentation by Sentolda Singh and Herman Loskamp, two of our new executive committee members who will talk about the state of AgMIP, and then we'll have the workshop charge. Come on, guys.
Thanks, John. Good morning, everyone, and welcome to AgMIP 7 and also welcome to Costa Rica. My name is Sentort Assing. I'm with the University of Florida, and together with Hermann Lotze Kempen from the Potsdam Institute of Climate Impact Research, we have been asked to give you a state of AgMIP. And I think I will do the first part and will hand over to the second part to Hermann. And I think there's no better way to start with talking about the people. AgMIP is about the people. It's a community of scientists, researchers, which have one goal: to improve what we do in the space of climate impact assessment, understanding climate viability, and how we can help securing food for the future. I'm sure we will get another, okay, next one, please. This is from the last workshop. I'm sure we'll get another slide very soon from this workshop. But I'm really happy to see so many people here. I think this is AgMIP, but I'm also particularly happy to see so many new faces, because it really tells us something about the state. There's a lot of interest from other people than just people which are only in AgMIP to contribute to AgMIP. Next one, please. So AgMIP, in a very brief summary, I think it's a distributed program about model intercomparison and future climate change. It's about multiple models, but it's also multiple disciplines, bringing people and models together. It started in late 2010. It has now close to 1,000 members, and it has more than 30 activities. And I'd like to go back to an old diagram, because I think it's still very up to date. It's a diagram which was created by the founders of AgMIP. It's in the key paper by Cynthia Rosenzweig in 2013, and really summarized the vision of AgMIP with having climate, crop modeling, and agricultural economic modeling as a center part. Their cross-disciplinary themes across the different disciplines. There are key interaction areas in there, like soil, water. We talked about water, pests and diseases, and so on. A very important part, even we have only very few people here for IT, dealing with the data, managing data, exchanging data, helping us to actually work together with each other. But it's not just about creating better models, which is probably part of here. It's also about applying it. We want to get better models to actually do something with it, to understand the impact of climate change in region up to a global scale. We want to help making decisions in this space. We want to help building capacity. So I'd like to stay with this diagram, and like to go around to see where we are, what have we actually achieved. And I'd like to say already now, I think many of the things I will show now would not have been possible without AgMIP. I think that's fair to say. Without having AgMIP, without the network, without the commitment, without the vision, this is the vision, I think many of the things I will show now would not have happened. I'd like to start with climate. Climate is really going through many of the activities we have. It's used in the crop modeling and the economic modeling and the relation to water. So climate is a very important part, and we do have a data set, a climate data set for agriculture application called AgMIP, which covers every part of the world where agriculture. So I think that's a huge achievement within AgMIP. More recently, these data have been further improved. And what this paper by Elliott et al. Is showing, with these improved climate data, they were able to much better simulate crop production in a large area in the US. So climate data has an important impact into crop modeling. They are critical, and we have seen now a huge improvement with some of these data feeding through in terms of our performance of our models. There have been many activities across the major crops: wheat, rice, corn, but also potatoes. And what we have shown there within AgMIP is that the multi-model ensemble medium is better than any single model. I think it's a very big, important outcome, which have been used in other applications now in AgMIP, and I'd like to point out the global one showing here, which really showed that by using multi-models for the major crops, the low latitudes will be mostly affected by climate change more than the high latitudes. I think that's a huge outcome, again, with what was made possible within AgMIP. While this looks like sort of a fixed arrangement, AgMIP is actually very flexible. There was a call last year about this time to respond to IPCC looking at the impacts of 1.5. And several of the groups within AgMIP were able to get in there. Several of them were able to submit papers in time. It was a very tight timeline. And 2 have actually made it in time. So we have actually 2 papers which will definitely go into the report. I think that's a big achievement, being flexible, responding to calls from society. There's been another larger activity across the different activities within AgMIP, the Next Gen, led by John Entel, in a special issue, which really tried to sort out what are the needs for our tools for the future to actually make them really usable for the users, that they actually can use the data which we generate within AgMIP. I think a big outcome is also we have now a data journal, which has now quite a few papers. I encourage you to go there, and I encourage actually most of you to publish your data in there, because it really preserves the data and makes them available for others to do other analysis on this data as well. I think a very big outcome is Impact Explorer was sort of outlined in the next generation to make data usable. There's much more going on the Impact Explorer on this one, and I'm asked to point out Amanda Evangard sitting down here. Please see her down at the poster area. She has a booth there, and she's more than happy actually to talk to you and take you through the Impact Explorer. It's a really cool tool to sort of translate your complicated information and makes them usable for other scientists, but also for other stakeholders as well. I need to do another round there. There's so much there. I like to point out scaling and aggregation, and I really like to point out at least one of our largest partners. It's Maxur. We have many partners. We partner with many different organizations and networks, but I think one of the most important ones is Maxur leading the scaling one, where we learned a lot of new things about what does it mean going from points to regions to globe, using different resolutions of data. I think there are many more papers than I showed, and here there have been a lot of activities within there, and I think again we learned a lot about scaling within AgMIP by working very closely with Maxur. Also more recently, there have been quite a few papers coming from Wallach and colleagues looking at uncertainty and prediction error. So we start learning about what are these, where's this uncertainty coming from? What does it mean? How does it change? Up to getting now a more theoretical framework of describing why the multi-model ensemble is better than individual models. There have been model improvement. You remember AgMIP, there are 2 I's actually in there. It's the intercomparison improvement. And I'm only aware of some of the things within the WIT team where model improvement has actually led to better projections. We could show that with having better models that you need actually less in your ensemble to do predictions or projections with your models. And then as what I also like to show, it came out of a larger activity within AgMIP, as a DFID project, which many of you I think have been involved, which included a lot of stakeholder engagement, and also developed the representative agriculture pathways, which has been done not in isolation in science. There has been actually a lot of ways being explored of how to bring the stakeholders in there and contribute and help developing the science and the way we communicate again this information to to the users. And this has been, I'm sure many of you are aware, summarized in terms of the results and the process in 2 book volumes edited by Rosenzweig and Hillel. There have been also new activities in there. We have now most recently the first paper on an intercomparison of models looking at pasture growth was just published, which is sort of one step towards livestock systems. For one of the other key interaction areas, soils, very important. There's a paper currently under review. We also have now new teams which have been formed on ozone. I think there has been an overview paper on ozone, a review paper. There has been also a paper on protocols for ozone intercomparisons. The disease team is becoming active now as well. There has been the first concept paper which just came out as well. And we have new crops. Canola started, I think, 2 years ago. They're doing all the intercomparisons. I assume there will be papers coming out soon. But just recently, a week ago, there was a new model intercomparison for a soybean formed. Okay. And I'd like to finish with this slide, which sort of tries to at least to integrate across different activities within AgMIP, where within AgMIP, we looked at different ways of estimating the impact of temperature. And in this case, temperature on its own, showing the impact of 1 degree increase in global temperature on global production. And what we learned in there by looking at different ways of how we approach it in AgMIP through different scaling methods, by looking at points, at gridded approaches, looking at experimental data which are available around the world, but also reaching outside of AgMIP into other approaches like statistical approaches. And what you can see in here is that between the major crops, which by the way supply 2/3 of all the major food around the world, among these different crops, you get different effects there. Like for wheat, you might get 6%. The bar shows the average. For rice and soybean, you might get a reduction of 2 to 3% per degree, whereas for maize, it might be up to 8 or 9%. But the key in here is that these different approaches, when you take into account the uncertainty as well, shown as error bars, it's actually all showing very similar results. So we have now a lot of confidence, at least on the temperature side, what it means in terms of temperature increase and effects on global production for these major crops. And at this point, I'd like to hand over to Hermann.
Yes, hello everyone. Thanks also for having me here this morning. I'd like to add that I'm one of the co-leaders of the global economics team, and I have to apologize. John mentioned that we just had 6 weeks ago a very successful workshop at the Joint Research Center in Seville, and that's why not so many of the economists are here this week, because it was just too much of travel. Nevertheless, I want to present you a few insights. Next one, please. On the integrated work we have done in the global economics team and also in the CGRA analysis. In the global economics team, of course, we are at the end of this line using multiple climate impacts translated through multiple crop models, and then using that in the global economics models to assess, okay, what's the impact of climate change and other effects on production, on trade and prices. And this is our latest paper, which is accepted now, where we looked at different shared socioeconomic pathways, so different socioeconomic developments, and we compared the impacts of crop yield changes and compared them to the impacts on agricultural market from ambitious mitigation, which you see on the right-hand side. And this has been done with 5 of the global economics models in the team. And what we see, I forgot to add, this is change in agricultural production by 2050. And by 2050, we clearly see that the impacts of production, so reduced agricultural production due to yield changes, the impacts from ambitious mitigation, meaning taxing emissions, increased use of bioenergy and so on, has actually a stronger impact and in most of the scenarios than the direct climate impacts, because by 2050 they are not that evolved. Next, please. And this is then translated into price effects, and what you see here as well. We also combined ambitious mitigation with residual impacts, and you see like higher prices due to the direct impacts of climate change, on average between 5 and 10%. And then if we look at the mitigation impacts, we are talking about between 25 and up to 35% on average. But you also see the spread across the models, which is of course the beauty of these ensemble runs, that we can really look at the uncertainties across the different models and model implementations, because for sure, like with any of these models, there are many differences, specific technical differences across the models. And this is also one of the important learning effects in AgMIP, in the model intercomparison exercise, that the modeling teams really learn from each other by doing it, by going through these exercises. The next, please. I have another bit longer presentation tomorrow on more results. We are also increasingly adding additional dimensions in addition to production, trade, and prices. Our Japanese colleagues around Tomoko Hasegawa had a nice paper in 2015 where they, based on the shared socioeconomic pathways, they assessed the risk or the number of people affected or at risk of hunger. And you see that depending on the socioeconomic development, you will have much higher numbers of people at risk of hunger in scenarios like SSP 3 or 4, more fragmented, less developed worlds compared to other shared socioeconomic pathways. And for sure, the impacts of climate change, the additional impacts, will have different effects on people at risk of hunger as well. Next, please. And we are having a paper under revision. We hope it will be accepted by May 15th, which is the deadline for the 1.5C special report. So I hope we'll get that done to look at the impacts of on food security from the scenarios we had looked at before. And then a very nice example of kind of the full integration across the coordinated global regional assessment activities. And this is the paper led by Cynthia, which has already been mentioned by Sentold, where we actually linked not only from climate through crop and livestock models to economic models, but also linking the global and the regional scale down to the household level analysis, where a number of households in specific regions were analyzed with respect to their vulnerability. And so one of the results, again, was the effect of climate impacts on agricultural prices, this time only with two models, farm and impact, and also comparing effects of mitigation and climate impacts. And then this was similarly looked at the regional level, where site-based analysis on crop yield changes for 1.5C and 2 degrees of warming were looked at. Here the examples, wheat in Pakistan and maize in Senegal. And then finally translating these effects at the household level in 5 different sub-regions of the Punjab, where then the effects also on economic outcomes at the household level, changes in poverty rates, changes in farm income were part of this integrated analysis, bridging all the scales from the global climate impacts through markets and then through the regional economic outcomes. So I think this was a very beautiful proof of concept that we are not only talking about this huge issue of integration, but that it can actually be done, and we can link these results all together and give this beautiful overview. And then as a final slide, which Sentold put together, so what have we learned so far, or what do we think we have learned so far? And there are a couple of bullet points now. There is a tremendous interest in this research community for the systematic comparison and multimodal assessment.
Santhold already mentioned that the crop model results show that the median reproduces best the observed yields. Key factors of crop responses are CO2, temperature, water, and soil carbon and their interactions. For the regional integrated assessments, we are extending methods for projecting changes in farm systems, so very different farm systems in the different regions. The global crop yield impacts project a greater vulnerability in lower latitudes and in earlier decades. Santhold mentioned that already also, and the model uncertainty is now better being characterized. Water is an issue and may compound actually the climate impacts in many regions. And I think that's one of the next big things we need to tackle. Agricultural prices, as I've shown, are projected to experience upward pressure from climate change, but also from ambitious mitigation. And that's, of course, a contentious issue. And you have to look at specific timelines. Part of the effect of the strong price effects from ambitious mitigation is actually the need for taxation of non-CO2 emissions, which are hard to mitigate. And we have to discuss more precisely how these policies can be implemented and what additional measures can be taken to alleviate these price impacts. Food security we have looked at, and that differs widely under different socioeconomic pathways, but we are just beginning to understand that and implement this. And there's a big opportunity to build resilience, adapt, and mitigate if we can anticipate the challenges by capturing crop system interactions. And I think these analyses show elements, building blocks of improving our understanding of these very, very complex issues. So that was our state of AgMIP outlook. We probably forgot a lot of items, but we tried our best to give a good synthesis at this point, and looking very much forward to more detailed discussions over the next couple of days. Thank you very much.
Thanks, Santhold and Herman. That was really a great overview. Thanks for that. Very helpful. Although Santhold, as you were coming towards the end, I was feeling rather exhausted and thinking maybe I needed a nap. But no, that was excellent. And Herman, your summary there I thought was very helpful, and a great overview for everybody to remind ourselves of what we've been doing. Well, great. So now I'd just like to, without further ado, ask Cynthia Rosenzweig and Anthea Whitehead, two of our other executive committee members, to talk to us about the workshop, why we're here.
Yeah, good morning, everyone. It could be good night for me because I'm on a different time zone, unfortunately. So Cynthia and I are charged with giving the charge, and I'll leave a lot of the enthusiasm to Cynthia because I don't want to take that away from her. I just wanted to introduce why I'm here. I'm part of the CGIAR. So I work for ICRISAT, which is the International Crop Research Institute for the Semi-Arid Tropics. And I think it's very important here to raise the profile of the CGIAR. I think there's several CGIAR members here. I can see some people from IFPRI, from CIMMIT, a few from ICRISAT. Anyone else? I think that's it. Anyways, the CGIAR is one of 15, there are 15 centers around the developing world. They were set up, I think many of you know, around the CGIAR. They're all about research for development. And I think they play a really key role in bringing the AgMIP messages to the stakeholders. So my aim was, for joining the executive committee, was to try to represent CGIAR with the aim of connecting the researchers to the crop physiologists, the crop modeling that's going on to influence our breeding programs, to bring in the policy and economics researchers more strongly, and especially to connect the CCAFs, one of the major funding programs around climate change and food security, to AgMIP. And I think that's been weak in the past, and I'd really like to bring that along. And I think we need to take advantage of this community of practice, the capacity development, the tools, the methods, and the knowledge exchange. I've been involved in AgMIP for the last 4 years since I joined ICRISAT in India. And we were responsible for leading the DFID-funded regional programs that covered 7 regional teams across Sub-Saharan Africa and South Asia up until 2017. The purpose was to establish these climate modeling teams within each country. And there were, I think, at least 15 countries represented. And this built the expertise. It made available the tools and methods to understand the climate change impacts, the adaptation options, both from a biophysical and economic standpoint, and design these adaptation pathways. And I think co-design the options with multiple stakeholders. And you heard about the Impact Explorer, and that's a visualization tool that takes some of these messages into a visual form. There's a talk after the break by Sabine Homan. She'll present some of the model scenarios as being fundamental to starting the conversation with stakeholders, but the actual stakeholder engagement across scales from farmer to policy level is actually the method to achieve the impact and change. And so that's a strong message that I'm giving you, is that while the modeling is a starting point, the stakeholder engagement is where we get the impact and change. And I think the CGE gives you access to this network of stakeholders at a country level, and also organizations like IICA here as well. So I think the role of AgMIP is a network, it's a community of practice, and it remains highly relevant, as you can see from the enthusiasm in the audience here. It uniquely brings together the diverse teams, creates a platform for innovation. It brings new science. It brings this collaboration between developing world and developed researchers. So I'm very enthusiastic to play my role as an executive committee member for the next 3 or how many years I'm allowed to. And I'll try and bring the CGIAR researchers along with me. Thank you.
Roll up your sleeves. Roll up your sleeves. We're starting the workshop. All right. So if we can go to the next one, because also I need to be close to be reading everything on the slides, because here are the objectives. So what we do every workshop, not just the global workshops, but also the every regional workshop that we have and topical workshop, we put up objectives in the beginning. And then at the very last plenary, we're going to put these back up and see if we fulfilled them and achieved them. So here they are for our week, our 3 days, and in some cases, 3 or 4 days together. First, we want to demonstrate how AgMIP can help address global challenges, such as climate change and the SDGs. And this is very much what we heard from Qasim Asrar this morning in his fantastic keynote. Second, we've heard about this as well, convene the agricultural modeling community and share the AgMIP vision. Latest findings, that really was a fantastic State of AgMIP talk from Sentold and Herman, the activities and the focus areas. This is linked in a way to the first bullet. We want to go further now to identify opportunities for major stakeholder-driven initiatives that we can actually work on together. So, and this is related to the 3 pillars of AgMIP, which Qasim showed: the next generation models and tools that we're always working on to improve all the tools that we work on together, the coordinated global and regional assessments, and you saw some of the results of those in the State of AgMIP talk, and then the sustainable farming systems as well. We clearly want to, and we're so pleased to be here, and thank you to Ika from me as well, to bolster the AgMIP initiatives in Latin America. So we're already engaged. There were great sessions yesterday. We had wonderful meetings with the leadership of Ika, and we're already seeing how we can actually move forward on those to really strengthen and really activate those partnerships. And finally, plan AgMIP strategy, activities, and outputs in the 1 year or 1.5 year, basically, because we usually hold these workshops at sort of about every 1.5 years time. but also the 3-year and even 5-year timeframe. So we're working both on, okay, what are we doing right now? But also what are the long-term strategy that we're developing? And that's one thing that we're working on with the steering council. And we're very grateful to their leadership and helping us to do that. Next one, please. Okay, very quickly, this is through the next 3 slides are what it's the overview of the agenda. So here's day 1. We're just finishing our first plenary. We're going to continue in our second plenary after coffee break, research highlights and opportunities. Then in the afternoon, we start our parallel presentations. Alex, how many will there be? 5? Today there are 4 parallel sessions, so you're going to have to choose or run back and forth to the different regions, to the different rooms, I mean. That's really great so that everybody gets a chance to present their latest work. Then we move into, in the second part of the afternoon, a very important part of our work together this week, which is what we're calling the working groups. These are the 7 topics. They're in your plenary. I won't read all of them, but you can see scanning down. These are major areas of our work together that we want to come together across our disciplinary groups and really see what the state of science is and what we can do together to plan next activities in these areas. So these working groups are going to meet. Do they meet on every 3 days or first and today and Thursday? So we're not going to do report backs today from the discussions, but we are going to be doing report backs from these working group sessions on the last day. Next one. Okay, day 2. We've gotten a few requests for community announcements. So tomorrow morning, anybody who has something that's going on in their own community. So for example, we're going to hear about the plans for iCrop-M, for example. So we'll offer an opportunity for that tomorrow morning. Then we continue our research highlights and opportunities. You can see there's just really a cornucopia of what all the great work that all AgMIP folks have been doing. Then we have a second round on parallel presentations. Then we have our reception. And actually, Carolyn, will you describe it? What we're doing for our reception this time. This is Carolyn Mutter, the international coordinator of AgMIP.
Thank you, Cynthia. So as most of you saw, as you registered and had, I'm too close to the speaker or something anyway. We have posters and activities that are displayed on boards in the downstairs area. And as we recess for coffee, this will be an opportunity to start to explore those, but we want to explore those in detail in our evening reception. So what will happen at the end of day tomorrow in terms of the plenary and parallel sessions is that we will pause and we will have food and drink and relax, and we will actually have some music and cultural enjoyment. And then we will all engage with the people who are, instead of presenting to a microphone in front of powered slides, are presenting to individuals who are walking around and using the poster as a backdrop for reference. We highly value these interpersonal interactions. They're an extremely important mode of exchange. And so we are mixing it up. And the whole point is to think about what matters for you, taking into consideration some of the challenges and objectives that Gossam set out. What is it that AgMIP can do that is beyond our individual capabilities that we need to work together as a community to achieve? And really think about that as you look at some of the examples of work underway both in this region, and we included the available summaries of the leader activities. There are, Senthold noted, there are about 30. We have poster representations of about 20 of those. So those of you who are new to AgMIP, one side of the downstairs has small posters with some of the highlights of those activities and the people who are leading them, so you can find them and figure out how to get involved. And the others are the poster presentations that are being presented together with food and drink. So that's the long version.
Thank you. That is the Walking World Cafe. I want to highlight the next two bullet points, because this is actually for all the days. So as I'm sure is already happening, the AgMIP Global Workshop provides an opportunity for interest group meetings throughout that are not on the agenda. And I'm sure some of you are already getting together, but just to say we often have, and if anybody would like to, for example, tomorrow morning, say anybody who's interested in XYZ, get together at lunchtime. So that's the final bullet. And then I do want to highlight that for the first time at an AgMIP Global Workshop, we are going to host a women's lunch. Now, first of all, men are invited. It's not exclusive, but the topic of it is how can we encourage participation by women in all aspects of AgMIP, from the regional teams, from the research teams, and also all the way up through the leadership opportunities. So that's what the topic of the lunch discussion will be, and all are invited. Next one, please. Day 3, plenary, continuing, and then we're going to day 3 is our planning day, really, research planning and opportunities. Where are we going? We're going to be starting to gather from all the groups. What are the real directions that we're going to be going in? We go back to our working groups for 2 more sessions. One is on regional integrations of models and disciplines. So that's going to be really focusing on different regional aspects. And then we go to our final time together to really, really come to a, we hope, plateau on where are we on our protocol, our next set of protocols that we're developing. All AgMIP work is based on protocols and plans and goals for AgMIP 8. So that is usually about on the 16, 18-month timeframe. And then we're going to have the plenary wrap-up. So we're going to have, this time really serious, though. We're asking for homework this time. Report backs from work sessions that are going to be on a template that we're going to be able to collect and capture. And we are going to ask those who organize side sessions on Monday that aren't really represented in the work groups to also use, we're going to be asking those groups to report back as well. Then what a very, very wonderful and important part of our plenary wrap-up is the perspectives from the AgMIP Steering Council. So we'll be asking Jean-François and Gassim for their collation of the responses from the Steering Council to everything that's been going on this week and in the past year. And then, of course, our final chance for discussion. So that's the agenda. I mentioned that yesterday there were side sessions. I just wanted to put them up because I know some people really weren't here yesterday. So there were all these groups that I think met yesterday, right? It's amazing. So that's why we want to hear from those groups in the report back on Thursday. Some of them overlap with the work group, so we don't have to have 2. I won't read them all out, but also if any of you who are here and seeing these for the first time, if you're interested, then we'll get you hooked up to these groups. The next one is, then we're also taking the advantage of being together on Friday to have 2 more meetings. One is on Latin American modeling and assessment activities. So that's a theme of the discussions through the entire week. So that will be continuing through Friday. And then we're also having a meeting of the executive committee. We saw the 6 folks who are in that with the research and region leaders. We call the folks who are leading those approximately 30 activities when they come together, the Leaders Forum. And so we're going to have a joint. Any members of the Steering Council, of course, are invited, and anyone who is still here on Friday and not going to explore, I mean, the fantastic, of course, ecosystems of Costa Rica, but everyone is welcome to see and really share in the discussion at that meeting, because we'll really be discussing again, how do we move forward? And I think the next one, okay, very quickly, there's 2 more slides. Let's just read them, if you could put them all up. Okay, so this is just to say, this is part of the workshop charge. Yes, and we need coffee desperately. This is just, I won't read all of these out, but this is part of the workshop charge. It's to really be thinking as you are in your discussion groups and your working groups, who are the stakeholders? Who needs this? Gossam calls this the push and the pull. So from the research side, right, we're pushing the research, but the stakeholders are pulling it basically from us. And we're working in AgMIP to have a balance between the push and the pull. So for example, so we've heard a lot about IPCC, but there are other assessments, other activities like EAT and Lancet, right? That type of work on the food and nutrition, UNISDR, and their global assessment report with the contributing to on the agricultural and risk basis, for example. So be thinking in your discussions, not just only about this is the next work that we're going to be doing on our research, which we must advance, but also who are the users of the information and how can we approach them? So the final slide is the homework. This is for the side sessions and the working group report backs. Everybody's going to get this who leads the session. And on Thursday, everybody gets 1 slide, and we're going to hear from all the groups. And you can see that it says stakeholders as part of it. So that's, we do ask that be part of the discussion. And of course, plans for 2018, 2019. With that, John, close up.
Yep, wonderful. Thank you, Cynthia. So I'm going to suggest that we reconvene at 11:30. We're about 15 minutes behind, and I think we can steal a little bit out of lunch probably, because it's really important to have a break and see our posters and enjoy some excellent Costa Rican coffee. So thanks everybody for a great opening session. See you in 30 minutes.
So welcome back, everyone, to our next plenary session. Just figuring out the technical details here. So we actually have 4 presentations now. It's the first of a series of research highlights and opportunities. And we'll start off right away with Pierre Matre on model improvements from model intercomparison. It's yours.
Thank you. Hello, everyone. I try to remember my first slide.
Oh, you can go without slides.
Okay. But I need to remember. Oh, you could all come around the computer.
So we've had a number of people who would like to actually share in the announcements of tomorrow morning that Cynthia offered. And so the protocol for that is that you may have one slide and, you know, maybe like 1 to 1.5 to 2 minutes, because we really need to move right through and get onto the sessions, but we do want everyone to be aware. So send your one slide to info@agmip.org and we will assemble them, load them, and then sit toward the front so you can make your announcement, and we'll move right through. So we're really delighted to be able to provide this, but we also need to not, to be organized in our approach.
Yeah, that we didn't have enough IT people. Stand up.
Okay, thank you, Alex. So, I'd like to start to acknowledge my co-authors, and I thank Frank Ebert and Lee Wong, who contributed to most of the work I will present today, and with the AgMIP team. So I will try to show how we tried in AgMIP to move from model intercomparison to model improvement and back to model intercomparison. So just a kind of a summary or recap of a bit of a history of the AgMIP that started with the crop pilot studies with 3 crops, the wheat, the maize, and the rice pilots. They all followed the same protocol with 4 concentrated sites in different regions of the globe where the crop was important staple crop in there, and trying to analyze the uncertainty of the models for these different environments. And then it was followed by other pilots on potato, sugarcane, and more recently canola, and soybean has been announced earlier today to start. The objective of this pilot was to quantify the uncertainty of crop models and to improve how crop models represent effects of multi-stresses and extreme climate events on the development of the crop and growth and formation of yield. The objective was also to quantify the impact of climate change on production and also on management time climate. And finally, to try to identify region-specific mitigation and adaptation options across the globe for these different crops. The main results really that came out of all these crop studies can be summarized in 3 points. The first one was really to quantify the uncertainty of crop model ensemble and identify knowledge gaps that could then lead to model improvement, as I would show. The second major result was that the error for different variables are often not correlated, which means that you have a lot of compensation for errors. So quite often the model simulate yield right, because it's quite often yield is the main variable to trying to predict, but for the wrong reason. So, and that we should worry about that and work on that. And the third one is that the median or the mean of multi-model ensemble is a better predictor than any single model in the ensemble. That was found by all these pilot studies. It was shown before by the climatologists, for example, but that was new for the crop models. Then all the different crops pilots carried on and tried to explore more the response of the crops to different factors like heat shocks and CO2 or temperature and drought. Here is just an example of a study by the wheat team where we compared the simulations of an ensemble of 34 models to the measurements from chambers on the effect of heat shocks during grain thinning or chronic elevated temperature during the same period. And as you can see here, the model were able to predict to simulate the impact of this change in temperature and heat shock pretty well. And you could see here the uncertainty, the uncertainty is actually quite low compared with the measured uncertainty on the measurements. We also analyzed the response of the model to CO2 in combination with temperature and water, for example, from phase experiment in Australia, but also from Maricopa. And we also analyzed not only yield, but many other responses, including a protein, and that was important. And similar analyses have been done for maize, for example, and rice. I think Kinbuchi will present results from rice tomorrow or today. And this AgMIP intercomparison approach is really a variable approach because it provides you the means to quantify the uncertainty of an ensemble of model, and that lead to better projections of yield and yield response to climate. And so it really brings an improvement in yield projection, but it's less useful in terms of process understanding, or you really have to work hard because you're not dealing with only one model, but an ensemble of maybe 30 models or more. So, but model intercomparison can further quantify the accuracy of individual model, not just looking at E-median or the median of the models, and focus on the difference in the model, why they are different. And so that brings to the identification of knowledge gap and opportunities from model improvement. And that's really the next step that we started in the last 2 years to go toward model improvement. So why we need model improvement? We need a model improvement to reduce the uncertainty of yield projections. For example, if you look at here, that's the decomposition of the uncertainty of yield response to temperature. So here you have a baseline temperature, an increase of 2 degrees and 4 degrees in temperature. And you could see here the variation due to the location, the variability due to the year, and here to the model. Now, as you could see, the uncertainty due to the model is comparable to the uncertainty due to the location and higher than the year. And also, what important aspect is that the uncertainty increases with the temperature as you increase the temperature, so the model becomes less certain, projection becomes less certain. Another important aspect why we need model improvement is to reduce the model the number of models required. Most of the pilot study who analyze the effect of how the error reduces when you aggregate model projections, found a decrease like that, exponential decrease of the error with the number of model, and you get to a reasonable, let's say, a reasonable uncertainty or when you get about 10 models. But it means you need to build an infrastructure where you are able to run 10 complex models. So really, if we could, through model improvement, reduce the number of models required to get to an acceptable level of uncertainty, that is an important achievement. Another one is that we need to improve simulation of key processes, not only yield, and increase accuracies of simulation. That's an example from the work done by the AgMIP team and the work led by Heidi Weber on canopy temperature. trying to analyze the skill of the models to simulate the difference between air and canopy temperature. And then in terms of improvement, it's also important for better support for application in relevant areas, such as assessment of climate impact, of course, and especially if you want to go and analyze the impact of extreme events where models have not necessarily been tested correctly, the evaluation of management options, or to better capture G by E by M interactions and support breeding efforts. That's an example that shows here, for example, how the importance of different traits will change with different management scenarios, options, but also with different locations. So, as I said, most of the pilots really focus on the model intercomparison, developing first a multi-model ensemble, then establishing simulation results using a temperature, CO2, water, nitrogen experiments, or doing sensitivity analysis to these factors, and then looking at differences between models and accuracy of individual models, not only the median. Then if you want to move to identification of knowledge gaps, you need to look at the main drivers of this difference and accuracy, try to identify that's led to the identification of key processes in individual models, because in different models there may be different processes that come up as being important, explaining the inaccuracy of the simulations. And so then you could identify the knowledge gap, and that leads to process understanding, and you need new research in terms of reviewing knowledge in the literature from experimental studies, but also designing new experiments to improve the model, and that could be potentially applied to all the models in the ensembles. So one of the first focus on improvement was on temperature. The reason why that the impact of temperature on yield is huge. And even though you could see here the red symbols are the observations, and the gray banding is 50% of the models. So you see that the 50% of the model are almost within the experimental error, but still you have substantial amount of models that are out of that. And another important point is that the correlation of the error is not necessarily for different variables are not correlated. For example, you take this model here, which has a low error for grain yield, but it has the highest error for leaf area index, and so on. So there's not really correlations. And also what we saw is that when you change temperature, it's what we showed before, is that you increase the number of models you require in an ensemble to be able to get to an acceptable level of uncertainty. So what we did is in the WIT group was to analyze the temperature response for different processes. This is just one example for phenology, where you see the different temperature response in 29 WIT models, and you could see the diversity of temperature responses, how the rates of development change with temperature. Some models consider linear increase of the rate with temperature, some others consider an optimal, and so on. And if you aggregate this data, you get to this type of uncertainty, where here you could see the red line is the median of the different temperature responses, and the gray banding is the uncertainty, the range in this temperature response. So you see in this range here, the uncertainty is not very large actually, but as you move away above the optimum temperature, then the uncertainty becomes very large. And that was found for different processes like photosynthesis, biomass production, leaf senescence, and leaf growth. For all these processes, the uncertainty is quite reduced around the optimal temperature, but as you move away from the optimal temperature, especially under the high ends, then the uncertainty becomes very large. There's probably one reason for that, is that most of the time models are tested in this range of temperature, or if you say this example for phenology, in this range. So where they do pretty well, if you look at that. But as you move away from this, and where we might in the future, then they become more uncertain. So we analyzed the the literature and discuss with physiologists, try to develop new temperature response for different processes. And here what you could see is temperature response for wheat for different processes. The symbol represent data we retrieve from the literature, and the line represent the temperature response function we proposed. And using this temperature response, we could reduce quite a lot the uncertainty in the model. So what you could see in this graph here is that the green banding is the uncertainty or the range of all the 29 models. And what you see here in blue is the uncertainty due to the different type of response when they are implementing in AgMIP or in serious quality. So you could see by changing the temperature response in these models, you get at least 50% of the uncertainty on this wool ensemble just come from the uncertainty of these temperature responses. What is also interesting to see is that the median I showed here is actually very close to the new temperature response function we present. And that may be an explanation why the ensemble give good response. It's because at the process level, when you aggregate them, they are pretty good. And at the end, by implementing this new temperature response in these two models, we could improve the simulation of all processes in the range of temperature up to 35, for which we had experiments. And we reduced by more than 50% the error on yield. We also worked on the effect of heat stress on leaf senescence, testing different models. That was done by a group outside the, let's say, AgMIP, that was used then in AgMIP. This proposed improved model for leaf senescence was implementing in different model and testing with the AgMIP with ensemble of model. And you could see here the effect of implementing this new model for heat stress on the uncertainty of biomass accumulation here. And you could see that the effect is stronger, of course, when you go when you are on higher temperature hands, when you really decrease the uncertainty of the simulations. And we tested that for different data sets. So for a calibration data set from Maricopa, Arizona. And then we use an independent data set from CIMMYT with location across the globe to evaluate the improvement. What you could see here is that the bias of the ensemble is very similar across the data set, but also for the original and improved model. So this bias represent the intrinsic property of this ensemble probably, and also uncertainties factor not considered by the model. What we really decrease by improvement by a factor of 2 is the variance between the model. So the predictive skill doubled at the end. And as this bias seems to be an intrinsic property of a given ensemble, it could be used as a value to quantify the bias in future studies where you may have less data to quantify this bias. What is important to consider is when we improve a model, do we reduce the number of models required in an ensemble? Could we go with fewer models? It's what you could see here for leaf area index and biomass production. You see how the coefficient of variation of a response to temperature changes with the number of models you have in your ensemble. And the dashed blue line represent the coefficient of variation of temperature response in the observations. So say that if we do at least as good as in the experiment, that will be the target. And you see that for leaf area index, in the original model, to get at that level, you need more than 10 models. But with the improved model, you only need 2 models. That's model taken randomly from the improved models. And from the biomass production is less spectacular, but still you have an effect. And for yield as well, you reduce the number of models required. So just before I summarize, just one point is that there has been 2 ways of doing the model improvement. One way was to really dig into the processes of a model and try to identify knowledge gap and try to improve. We tested that. I presented for 2 models, but actually we tested it in more models with the same results. Another way is what was done in this study here, where we collectively analyzed the gap knowledge, proposed a few possibility of improvement, and then let the group do what they think they should be done in their model. So most of them, they improve the temperature response of leaf senescence, but they also improve some other aspects like recalibrating for phenology for some model, for instance. So that's another way of kind of doing it. So to summarize, from model intercomparison, provide the multimodal ensemble provide a mean to reduce the uncertainty, increase the accuracy of projections. And as I showed, the crop models have been tested now through, thanks to AgMIP efforts with increased temperature, heat shocks, elevated CO2 drought, and so on. And that really helped identify model deficiencies and knowledge gap. Then to move to model improvement, we show that large part of uncertainty in multimodal simulation can be explained by variation in temperature response functions that really should be improved in many models. But that's just one example of improvement, and we really need more systematic evaluation of knowledge gap to meet the demand for agricultural model projections, especially in terms of the response of a model to CO2, nitrogen, water, both drought and flooding. And finally, this improvement has been a very large effort of a group because you really have to go into the model to understand their response and so on. And really, if we want to move on with model improvement and improve a model, the next generation of agricultural model really need to be more transparent, to expose more the algorithm, the equations behind the software, and allow for more systematic intercomparison at the process level, not only for yield or KM. And that's something we're trying to do. It's through an initiative called AgMIP for agricultural model exchange initiative that actually was started during the AgMIP workshop in Florida. We had a side session on that, and then we followed since, and I will give a presentation of the work we're doing in this initiative on Wednesday. Thank you.
Yeah, sure.
Yeah, thank you very much, Pierre. Just to let you know, there was a discussion time scheduled for the end of this session. I fear that we have to sacrifice that because we have to make sure that we go for lunch between 1 and 2. So let's see how it goes. Please join our colleagues for discussion then later during the breaks. And now we continue with John Antle on key findings from integrated climate, crop, livestock, and economic assessments of farming systems. That's not the one. You can use this one, and it also.
Great, thank you. So what I'd like to do is particularly for the benefit of those of you who are relatively new to AgMIP, to give you a little bit of an overview. It says key findings, but really a bit of a taste of the methodology and some of the key findings. And in our regional impact assessment working groups, we will also have some colleagues who were involved in some of this work also talking in a bit more detail about the methodology. What I wanted to do starting out is to really, well, let's see, maybe I should go back to the slide. Just really express my gratitude really to all the people who were a part of this project. And I really have to say I'm presenting on their behalf. It's just impossible to acknowledge all the people who were involved in this very large 6-year project. Fortunately, a few of them are here, and like I said, we'll be sharing their work with you in some of the parallel sessions and the working sessions. One of our right up front, I think one of our most important things we learned from this project, which was funded by UK AID or DFID to a large degree, and which involved teams in parts of these 4 areas of sub-Saharan Africa and three regions of South Asia, was that it really is possible to work together to co-develop and then implement this kind of regional assessment research. And I think that's really important because I would argue up till now, so much of the climate impact assessment research has been done by people in North America or Europe and a few other countries in the world, like perhaps Japan and Australia, you know, covering the whole world and trying to represent what climate impacts would be and how adaptations might work in all the rest of the world. And we really need to move to a different paradigm, I think, where, you know, and that's particularly unfortunate because that means the people who are most able to cope with climate change, and by the way, the people who are causing most of the climate change, are doing the analysis to represent the likely impacts on the people who are really impacted by climate change and largely not causing it. And there's something fundamentally inequitable and wrong about that. And so I think one of the things that we are particularly, I would say, proud about, and I think one of the most important things we learned from this work is that it is possible for people in those regions to represent themselves and to take these tools and to use them successfully. So here this photo shows really just kind of the leaders of that project. And again, I can't identify them all, unfortunately, but behind that group was literally another probably 150 scientists or so working on this project. So just a few quick words about this methodology. And again, that 2 volumes that Sentold showed you a picture briefly that's available, by the way, open access online, freely available, represents really the early part of this work. And then we're working on another volume for the sort of second phase of this work. But also I wanted to just point out this document we produced on the protocols for the AgMIP regional integrated assessments, which really walks through a lot of the detail of how we actually did it. And so is really important both, I think, as documentation and also, you know, a sort of here's how you can do it if you want to pick it up and do this kind of thing as well. We've used this graphic for a long time now to try to portray the concept we're working on here, where, you know, the global map represents the fact that we are taking global model simulations from our global modeling team and things like global socioeconomic scenarios, the SSPs, and using that as sort of a starting point then for designing scenarios by these teams in the regions, by the and when I say team, I mean the scientists working with the local stakeholders to really envisage what they think are meaningful future pathways that sort of span the space of plausibility for their work. And then we really come down to the farming system level and focus on a particular farming system. We call it regional, but by the way, regional here you might interpret as subnational in a lot of cases. Typically this is within a country, although it could of course cut across country boundaries. And what we're trying to do then is through this methodology that I won't go into details here now, but this sort of, you know, distribution diagram there and the little map, and then the distribution is to represent the fact that we're really trying to not represent, you know, just an average or typical farm, but really the distribution of course, we know these systems and the people in them are very diverse, and we're trying to represent that heterogeneity, that distribution, particularly of impacts on farm households. And so that's what we're trying to capture. And of course, ideally, we might then feed back this kind of regional analysis, aggregate it up and feed it back to the global analysis. As I think Herman mentioned, we had a meeting a few months ago in Sevilla where we were talking about the need to start implementing that feedback process a bit. And throughout this meeting, you'll hear us talking about the CGRA, the Coordinated Global and Regional Assessments. And as we scale this sort of work out, increasingly we'll be able to do that sort of thing. Well, here's just another graphic that I think was shown briefly earlier about this phase and some of the components that are involved with it, which, again, very important work on climate, and probably those of you who work on climate know about this methodology that the climate group really developed to utilize the large climate ensembles to represent in a region the sort of space of potential climate change. And then very fundamentally, like I said before, this engagement throughout the process, from the beginning, the engagement with the stakeholders to really co-design, visualize, the way we think the world could be changing out into the future, and then to nest the analysis within that visioning process, using something that we've come to call RAPs, or representative agricultural pathways, and then really this kind of iterative process of analysis, review by stakeholders, more analysis, and so forth. This is a graphic from, I'm going to talk in a little bit of detail, that to the extent I have time now, about work that the team that was working in Zimbabwe and Malawi and Mozambique, led by Sabine Kitui, Homan Kitui, sorry, got your name backwards, who really led that work. And Sabine, please stand up and take a bow. And I'm going to highlight, that team's work here a bit, but, if I wish I could highlight a lot of other teams' work as well. And again, like I said, in the parallel sessions, you'll have a chance to hear more about that work. But, the way they implemented this process really was this iterative process of working with the stakeholders. And they have this very nice story about how when they first started out and they went to their stakeholders, and the stakeholders said, sorry, that's not good enough. You guys have to think out of the box more. This is not good enough to do what we need to be done. And so they had to go back and think harder and redesign their work. And so that really, is a wonderful illustration of how important, as I always like to put it, through this process, we are really learning from, we are getting information and data from our stakeholders. It's not that we're giving them information, we're using them to get information to do our analysis. And then hopefully we turn around and provide them something back that's of value to them. Well, how do you summarize that kind of analysis across all these different regions? Well, but one of the beauties of this, because we use this protocol-based approach of this regional integrated assessment method, we feel we can actually put these data together and to varying degrees actually look at it together and try to draw generalizations from it. Although there are certainly big challenges with that. And so this is just one of the graphics. I know it's not a great one, and we were thinking about how to use like bubble graphs or other things to visualize this better. But what I want to emphasize here is just that, so what these columns represent are results of different scenarios run in these different sites across Africa and South Asia for, different scenarios defining either sort of current world conditions or future world conditions, different climates. So you're seeing the variation due to the different climates. And we're trying to display 3 dimensions here. One is that the average impact, and here when I say impact now, I'm going to mean in terms of just their household farm income. But we're looking at the average impact, which is on that dimension, called P net impact there in that diagram. But we're also trying to, and that's sort of the one that most analyses you know, until recently have focused on. And if you look at that scale, you see that, you know, for a lot of the households in regions represented here, you can see that scale goes from negative to positive. In fact, the 0, unfortunately, we couldn't get the software to put a 0 in the middle there, but you see 5, it's pretty close to 0. You can see that, you know, by the way, the green and the, the red bars, and it's probably hard for everybody to read the labels there, but the red bars and the gold and the, yeah, let me see. Sorry, I'm so far away, I can't read either. You can see that okay, yeah. Sorry about that. Anyway, you guys in the back of the room are probably challenged to read this as well, yeah. Well, first of all, yeah, so let me just try again. So, you know, we've got these gold results. So what we did is, this is showing the results of 2 kinds of scenarios. They're both climate impact. One is under current world conditions, and then the other set is these projected future conditions from the pathways that the stakeholders and the teams develop together. And so the gold and the green are from, you know, current world, and the blue and the red future world, where the gold are positives, as you can see, somewhat positive, and the greens are negatives. And then in the future world conditions, blues are positives, reds are negatives. And so one of the key insights is that what we find from this kind of analysis, where we really do represent the heterogeneity, both in biophysical and socioeconomic terms, is that it's not that all of Africa is losing from climate change. In fact, there will be winners and there will be losers. And in fact, in some regions, there might be substantially winners. And so here on this axis, we have the percentage losses in farm income, and in the vertical axis, we have the percent of the households that are vulnerable to loss. And so what we're trying to do, in other words, in this approach, is to get beyond just this looking at the average, which, you know, notice, if we did that, for a lot of folks, we would say, oh, no impact. So nothing's happening, no problem. But in fact, within that heterogeneity, there are still substantial losses. And you can see these folks are highly vulnerable to large losses, even though the average impact in some cases may not be, you know, I don't know if you want to call that 20% large or not, but, you know, that's substantial. But when we see that, you know, 90% are vulnerable to, you know, very large absolute losses, that then tells us a very different story. And so one of our other major messages is that vulnerability can be high even when average impacts are small or even positive. So even in a region where we see positive impacts, there may be a substantial share of the population that are losers and can be losing quite substantially. Guess I don't need that mic anymore. Well, how am I doing on time? 3 minutes. Oh. Oh, thank you. Turn that back on. Thank you. Well, okay. Well, let me just move quickly here to help Herman out and the rest of the people who wanted to talk this morning. Well, so I'll just highlight a few points about this Zimbabwe study that I was mentioning that illustrates. So, you know, that's our big picture. But then, of course, within that big picture, each one of these regional teams has its own story to tell, which, as you can see from the diversity of that previous diagram, is not the same in all these regions by any means. One of the key elements in this methodology, as I was mentioning earlier, is this development of agricultural pathways and scenarios, what we call the RAPs. And the Zimbabwe team in particular focused on a business as usual, a green, a sort of sustainable pathway, and a gray, a sort of less happy, less sustainable pathway. And then after looking at that future, that impact under sort of future world conditions, as well as current world conditions, we looked at adaptation packages. And this is again where the research teams working with the stakeholders thought about the kinds of adaptations that they thought were both important and feasible to do within their context. And like I said, in the Zimbabwean case, the stakeholders really pushed the team to think more about systems that were more different than the ones they were observing today. And I think that's one of the other things we've learned from this work is that, that thinking out of the box, looking 10, 20, 30, 40 years in the future is a major challenge here for us to contend with in this kind of work. Now, let me see if I can get this to respond. Okay. Again, summarizing some of the analysis from the Zimbabwe case, again, contrasting sort of current world versus future world conditions, we can see, this is an example where the average impact looks very small. So again, if we just looked at average impact, we would say, oh, Zimbabwe is, a lot of people would interpret that lower graph and say Zimbabwe is not vulnerable to climate change. But in fact, when we look at within those households, we see that perhaps 50% are vulnerable to some degree of loss within that zero, sort of average impact. If you think about it, if the average is zero and there's a variance, some people are gaining, some people are losing. And that can differ according to the scenarios under the current world and the future world. And you can see that, in fact, under the future world, even there, to some degree, the vulnerability may be somewhat less just because of the progress that is projected to occur between now into the future, even with climate change. But then we could further adapt to lessen that impact, that vulnerability. And so here is some data just illustrating the analysis of the adaptations that were studied, which again, I won't go into in any detail, but as you can see under the green future, better success at reducing poverty compared to that more pessimistic gray future, but even there may not be good enough. And so, I think one of the other major lessons from, again, not just this case, but all those teams together was that because if you look across the different adaptations that were studied across the different regions, in some cases, they were finding that potential adaptations, really system improvements, could have very large positive benefits offsetting climate impacts, whereas other regions less so. One of the things I'll just end with then is, as we've mentioned a little bit already, one of the parts of that project was to work with Sander Janssen, his team at Wageningen, and Alex Rain was very much a leader in this as well, and a number of other people developing the AgMIP Impacts Explorer. The idea that, okay, all of this information like I've been showing you, again, how can we put that in the hands? How can we make that accessible to our stakeholders, not just in the regions, of course, them, but also people, in the global community who want to have access to this information and at various levels. And if you look at the Impacts Explorer again with our colleague who is here to help demonstrate it, you'll see that there are these different sort of levels at which one can access that information. Okay, let me wrap up. I think there's one more slide. Oh no, great. That's my last slide. I just wanted to end with that. So thank you very much. I think I was pushing the wrong button, actually. I guess this is the one that, yeah.
All right, thanks, John. And we are now continuing with Alex Rain on impacts to agriculture and food systems with imposed limits to climate change.
All right, thanks, Herman. So I'm going to actually take what we've seen already in terms of the specific crop model improvements, the regional assessments, and try to take a big step back and show really the first implementation of the AgMIP coordinated global and regional assessments, which were motivated by this IPCC and UN Framework Convention call for more information about what a world would look like with 1.5-degree warming. I'm representing a much larger team with, you can see the names there. This was a rapid assessment that was put out as the IPCC put out their own call. But let me just start by reminding you all of the motivation behind the coordinated global and regional assessments. As we just heard from John, there's a lot of work that we can do at the local farming system production level to understand how the households are balancing different production facets of their farm, and the specific crop production, interactions with livestock, markets, and other things like that. But of course, these regions, if we aggregate them up, give us a global picture of total production. And that global scale is often the scale which interacts with global markets. And in that sense, we can track that production as it goes around the world and affects prices and other information for regional markets. And that in turn changes the incentives of what those farmers are doing. And as you can see now, we've completed a loop that connects biophysical models with economics models and connects regional and global perspectives. So the idea behind the CGRA is to build a framework that allows us to track and connect inputs and outputs for modeling systems at these different disciplines, at these different scales, and to then apply that framework for questions around climate, sustainable development, policy, and scenarios around nutrition, food demand, things like that. So this was developed actually back in 2016. We had a special workshop to think about what a CGRA would look like. And there was a paper on that, but this was also updated recently in Cynthia's paper in the Royal Transactions. These are all the different applications that we see for the CGRA framework. There's too much on here to go into full detail, but what I wanted to point out is every time we do a coordinated global and regional assessment, we're interested in things like extreme events and shocks, current and future climate, and sustainable development. We are also, of course, interested in facilitating stakeholder interaction around 4 main topics: adaptation and mitigation, as well as agricultural policy and food security. And within any of these categories, with any of these concentric circles here, we envision a set of scenarios that allow us to test these coordinated global and regional frameworks. So what I'm gonna now zoom into is a specific mitigation scenario that asked us the question about this 1.5-degree world and how we could get there. And of course, the reason we're looking at this is because of the Paris Accords and the Paris agreements that came out of the COP in 2015. And I think most people in the room are familiar with this, but 197 countries have now committed to restraining global surface temperature warming from the pre-industrial conditions to below a 2-degree net warming, and to try to stabilize that at 1.5 degrees above pre-industrial conditions. So the big questions that come out of that is, well, what's the difference between these low levels of warming? What's the difference between a 1.5-degree stabilization and a 2-degree stabilization? What is the balance between the mitigation and adaptation burdens that come along with these ambitions? And then finally, what are the major uncertainties as we have now built this big framework? And I want to just make sure I emphasize here, this 1.5-degree global warming above pre-industrial conditions, we are already in the year 2010 about a degree above pre-industrial conditions. So we're really talking about an additional small change in climate. But as you'll see, a lot can happen with a small change in climate. So the way the framework was constructed, here we're actually showing the similar graph that Herman previewed earlier. But you can see now we've lined up 5 different climate models on the global level. We've created regional scenarios for that, but we've also passed the climate information into crops on a global scale, into global economic models. And then we are following a similar path on the regional scale to give us crop and economic information so that we can track inputs and outputs through these direct black lines. That's the passing of inputs and outputs. But we also have facilitated ways that we can compare for perspective checks and consistency checks between what's happening from a global modeling perspective and a regional modeling perspective. And within these loops, there's interesting information on extremes and how agricultural systems might change. And then these feedback loops, these are the actual mitigation, which tends to come from the kind of socio-political and the economic realm, and affects the climate itself and starts this whole loop again. So this is the framework, the models that we're trying to build. So let's kind of go through. This is what we actually found. The first thing we did was we partnered with the HAPPY project, which was a set of climate models that were designed to specifically ask this question of what an additional 0.5 degree of warming would be to get to that 1.5 degree world. So here I'm presenting the rain-fed maize growing season temperature and rainfall change for the 1.5 degree climate stabilization and for the 2 degree climate stabilization. And this is the ensemble of 5 different GCMs, each of which was run with many individual ensemble members, somewhere between 84 and 500, if I remember, 83 and 500. And you can see, of course, that for temperature, for the most part, there's warming across all of these agricultural areas. But it's particularly noticeable in the 2 degree world that this is not an even warming. Some places warm more rapidly than others. And that is from local feedbacks. That's also from things like the latitude and land sea circulations and other things that can come into play. And of course, for rainfall, there's a lot of regional variability. We tend to see more rainfall in the monsoon regions of South and East Asia, and a lot of other regional patterns that you can read about if you'd like. We have a whole paper just on the climate for agricultural regions. Of course, we take those climate change projections and now we can drive global gridded crop models, which we have been working with the GGCMI group to build up an archive of major climate system responses or major agricultural system responses to these types of climate changes. So this allows us now to build an ensemble of 3 different global gridded crop models, each driven with climate change information from these 5 global climate models. And now you can see for the 1.5 and the 2 degree world, changes in production or local yields for maize, wheat, rice, and soy. And here we're just showing rain-fed conditions, but we have this also for irrigated conditions. And a couple things quickly to note, we do include CO2 benefits in this situation. And these CO2 concentrations came directly from that HAPPY project. And you'll see that these are going to cause a little bit of trouble as we start to track our uncertainty. So let's do that. When we look at the total global production changes, and here we've plotted out 4 different horizontal box and whisker diagrams. The color of the diagram tells you the crop species. So red is maize, green is wheat. Then we have rice and soy. These are the major 4 commodities we were exploring. The red dot represents the median across all 15 combinations of climate and crop model. And you can see there's a pretty substantial spread, especially in maize response and some of the other crops. But also notice that maize tends to be negatively impacted while the other 3 crops are slightly more positively impacted. And some of you agronomists might right away say, oh, there's the C4 crop and the C3 crops separating themselves in terms of their response to CO2. So we can actually ask that question and say, okay, of those 14 or of those 15 combinations, what's the uncertainty that comes from the climate models? So here now we're just looking at each climate model, and you can see the uncertainty is much smaller than the overall spread, and the main storyline still holds, which leaves, of course, the crop models as where a lot of the uncertainty is coming from. And we can go even further and ask that CO2 question by saying, what would the difference be between including CO2 effects and not including CO2 effects, or holding CO2 constant? And here I have to help you interpret it. The dot represents with CO2, and the other side of the bar is without CO2. So you can see that these 3 C3 crops that were positively affected, when we take the CO2 effects away, all move to the other side of the 0 line. So we have CO2 literally changing the sign of that production change. We can also compare the 1.5 and the 2 degree world. Again, the dot represents the 2 degree world, and the other side is the 1.5 degree world. And you can see that in some situations, the difference between 1.5 and 2 is the difference in the sign of those production changes. However, when we don't include CO2 effects, all 4 crops, no matter which world you are, have a reduction in total production. All right, we can take those now global production change numbers and feed them into the economics models. And here we've done that for the IFPRI impact model and the farm model that's run out of the USDA Economic Research Service. And it's a little bit hard to read. I apologize for you in the way back. But let me talk you very quickly through. We have 4 commodity changes. And here you see 15 different combinations, again, climate and crop models. So there's a production shock, which is converted by these models into price shocks and pressure on agricultural areas. So we are now able to see the basic story typically is that if production goes down, the markets respond by increasing the price, and you have a shift in land area to try to make up for that consumer demand. So we've done this for the 1.5 and the 2 degree world, and we've done it for 2 different models. And maybe a better way of understanding the uncertainties, oh, I should have said one more thing. We also looked at the replacement that is associated with a specific mitigation policy. So everything I've shown you so far has just been that direct climate effect. But of course, you don't get a 1.5 or a 2 degree world without some substantial mitigation. So the farm model ran a set of mitigation scenarios where there was heavy use of bioenergy. And you can see that this big increase under the mitigation scenario in bioenergy, which is largely in their models taken from cropland. I think this is a 16% decline in total croplands, and grasslands, which is I think about a 4% decline. So this is a big pressure on the agricultural systems to have that mitigation happen. So now we're going to look again at uncertainty, but now at the price realm from global port prices. And what you're seeing here now is 30 different models and some uncertainty across the price, for example, of maize. The 30 models represent 5 different climate models, 3 different crop models, and 2 different economic models. That gets you 30 combinations. So we can, again, disaggregate that and look at the source of uncertainty from climate models, not so large in comparison to the crop models. But likewise, the economic models have some big uncertainties, although surprisingly, not so much for wheat. And we think that has something to do with replacement rates. As maize yields change, sometimes systems move into using wheat instead. So here we can track that through. And again, we're going to ask some questions about the way this was set up. So first of all of what we've done so far has been SSP1, which is a very sustainable economic pathway. But if we had used SSP2, as you can see here, it wouldn't have made much of a difference. Using a situation without CO2 effects has a big impact. Again, the commodities that with CO2 have a decline in price now all have increases in price. So without the CO2 effects, we have a very strong and clear signal that production goes down and prices go up. Again, when we include CO2 in some situations, the difference between a 1.5 and a 2 degree world, the opposite sides of these box and whisker diagrams, sometimes crosses 0, or it changes from a not very clear signal to a much more prominent impact. When you don't include CO2, we're squarely in the price increase range. And then finally, this mitigation scenario that I mentioned for the farm model, when we look at the direct pressures that come from that mitigation scenario, here now what we're looking at is the open circles on the left here are if we don't include mitigation on the agricultural system, and on the right is if we do. And you can see that the mitigation itself has had a dramatic impact on prices, and likewise on the land area, as we saw before. So we can track these things. We've now kind of followed the global side of the CGRA, but it's important also to look on a regional basis. So here what we're looking at is some kind of case study examples where we have a cross section of 3 sites that go kind of from southeast to northwest across the United States. So we have, we're going from the west to the east. So we have Colorado, Iowa, and Georgia. And in each of these places, we have locally calibrated a model. That's the open box and whisker, and compared it to what the global gridded models say for the same crop in the same location. And that's what you see in the gray boxes. And there's a lot of information on these slides I don't have time to go into, but we've plotted out the specific models so you can see how the different crop models fare. And overall, you can see there's some broad agreement here, but also some differences. And these differences could come from a more accurate representation of local soils, local weather, local management, even local cultivars. So this is an important reminder that sometimes you have to zoom in to see what the actual local effects would be if this was your particular region of interest, even when you have those global studies. We can also do this for the regional integrated assessment regions. In this case, we're looking at Punjab in the Pakistan and the very important cotton wheat systems for that region. So here we have taken the global economic model results and compared them to the types of systems analysis that John was just showing using the TOAMD model. So what you're seeing here is the South Asian Pakistani market price changes for cotton and wheat, and compare that to our local simulations of the yield changes. So you can see in this case, we have slight increase in price, but also decrease in yield. And you can imagine that those push and pull against each other. When we get to the 2-degree world, that was 1.5 before. When we get to the 2-degree world, the prices for cotton actually come down in addition to the yield being down. Now that's a double hit. Then now we have lower prices and less of that coming. So that's a big challenge for Pakistan. And as you follow that now into the farmer vulnerability, the net returns and the poverty rates, you see in all cases conditions that are not what we would like to see going into the future. So we have a fair number of vulnerable farms, lower net returns, and increasing poverty in these cases. So this is an important reminder that when we are looking globally and seeing in some cases small impacts, you do have to zoom in because there are farming systems and particularly vulnerable populations that may fare very poorly in these situations. All right, so I've powered through this. There's a lot of information I hope you can see that we don't have time to go into today, but this is a demonstration of the types of systems we can really zoom into. The paper that I've been showing is currently in review, and we're trying desperately to get the April 15th acceptance so we can have all of this in the IPCC. But even if we don't make that, that paper is coming forward, and we hope that can go forward. So let me review the main findings. This was the first coordinated global and regional assessments within AgMIP to really be implemented. And in the process of that, we've developed new infrastructure for multi-scale, multidiscipline, and multi-model assessments. We've looked at the direct impacts of 1.5 and 2-degree global warming worlds and see that there are substantial changes in prices in agricultural areas, although there's differential impacts by species. But we have noticed that the CO2 effects remain a major source of uncertainty as we're looking at that. Now, what I showed in those uncertainty plots was with CO2 and without. I would argue that without is an implausible future because the CO2 effects are definitely not zero, but it gives you the range of the type of impact that we're looking at in terms of the uncertainty, and we need to zoom in on that. Finally, last 2 points here is that there is disruption from mitigation, which we have seen is larger than the resulting adaptation burden in that new climate stabilization. And this supports work that Herman was mentioning earlier in terms of the overall impact of mitigation and adaptation at this range. And then finally, the regional analyses reveal pressures that in many cases go against the global perspective, and we have to keep those in mind. Last thing I want to say is from this coordinated assessment process, we have a number of papers that are either directly involved or have been participating in building up AgMIP CGRA activities for the 1.5 degree report. We've already heard about Cynthia's paper, which is a really nice breakdown even of additional uncertainties in this and also connections to other modeling systems. I mentioned we have a climate-oriented paper. Babacar Faye and Heidi Weber and Dillis and I believe several other people all worked on a project looking at 1.5 and 2 degree world impacts on cereal yields in West Africa. John and colleagues have done a study looking at Pacific Northwest systems and mitigation incentives for farmers. And then Hans van Meel and Tomoko Hasegawa have global economic studies that talk about these balances from an economic and also from a health perspective between mitigation and adaptation. And just in the hallways here, I've had additional conversations about the AgMIP wheat team exercise in the 1.5 and 2 degree worlds, and 2 different studies in India that are underway on the same topic. So with that, I thank you for your attention.
So thanks, Alex. Figuring that's a lot of information we are getting here in the morning. So we're getting now to the last presentation of the morning by Sabine Homan-Kitui, linking integrated assessments and policymaking to enable uptake. Please, Sabine.
Thank you. Thanks, John, for giving me this floor. Yeah, I would like to ask this question: why linking science and policy decision making? I'm presenting some lessons from an initiative in Southern Africa by ICRISAT, Oregon State University, and many others. We recognize that policymakers need information to cope with the challenges ahead of agriculture, and science can provide credible information to this end. We recognize that there is a great need for transformation in agriculture because we have these challenges of vulnerability related to small farm sizes and low productivity, malnutrition, food security, insecurity and health, resource degradation, conflicts over biomass, increasing global fragility. We believe that as scientists, we have opportunities and we have the task to address these challenges into opportunities so that transformation can unfold. And beyond AgMIP, we have many approaches that are helpful for that. In our world, we look at household dynamics, gender issues, market-led approaches that integrate profitability, equity, and agency, and use systems modeling, systems dynamics for managing these, and social learning for managing these transitions. I'm mentioning all this because there's more to AgMIP and we embed AgMIP in our science as we go. Specifically in Southern Africa, I would like to share with you that we have a huge potential to benefit from technological transformation. Because we have systems that are largely driven from the nutrition side by maize consumption, which goes along in this dimension with malnutrition and with food safety, insafety. Then on the farming system side, systems are very much dominated by maize production as well. In this context, climate vulnerability. So women are the particular agents of change in the system because they influence the decisions about diet. And on the other side, they gain a lot of influence on farm management as men often work off farm. So we also have a huge potential for institutional innovation, especially if you look at this map on fragility in the last 10 years. All the red countries have increasing fragility. There are few countries, especially in Africa, with reducing fragility. And of course, that affects the institutional ability for transformation. Why should we work together, scientists and policymakers? First of all, we want to acknowledge that we are together on a bumpy journey and we need to work together. And there are three particular research outcomes that are helpful to guide the future of agriculture. Number one, diagnostics through integrated assessments and scenarios as we do them in AgMIP. This helps us to characterize current systems and potential future states. Impact of climate change adaptation. That alone is not enough. We need engagements with stakeholders for influencing the deeper structures, governments, and policies, so that the institutional context unfolds, that these farming systems can move forward and upwards towards a better future. And number three, we need science outcomes on outreach, on how can we accelerate this change, on how can we perpetuate innovation to unfold. And therefore we need communication like Impact Explorer targeted to particular audiences. And we need capacity development so that in these regions where we want to provide our information to, people are capable of taking it up and adapting it to their particular challenges. I would like to show you feedback from AgMIP stakeholders, all right, at the end of a 4 years engagement process from Zimbabwe. Here you see the provincial level extension head. We also have some different national level representatives. It worked before. It was, no, I'm not good in telling jokes, please. Maybe somebody can volunteer. The summary would be better from the African representatives than from me.
Engaging to communicate. Engaging with AgMIP scientists gives us an opportunity to communicate the challenges that we are facing on the ground. So the challenge now is we come up with the relevant crops that farmers can produce, with the production techniques that would help them produce sustainably and meeting their food requirements.
We are looking at more sustainable production. In other words, we'll be looking at the environment, we'll be looking at gender issues, we'll be looking at youth. How do we incorporate these components into our development and avoid an environmental catastrophe, where we are looking at commercializing agriculture, which entails mechanization, opening up of new land, obviously leads to land degradation. And, you know,
I think livestock production systems are very important to Zimbabwe's food and nutrition security today, and they will remain very important in the future as climate change happens.
We need to ensure that we also are there to also promote social policies that are there to ensure that women are not disadvantaged, to ensure that women are put in the mainstream economy and they also participate in terms of the economic development of the country. And also to ensure that the gains that we have achieved so far in terms of gender equality and women empowerment, we still carry them over in our policies that we develop.
Okay, thank you. This is a background where we are now. I would like to illustrate here on how we got there with these stakeholders. Our engagement process has basically 6 steps. It starts, number 1, with revising the lessons learned with other projects, AgMIP as part of one project on a patchwork of collaboration. 2, right at the beginning, we develop our multi-model framework. We set up the models, assessing climate change risks, but we also set up the network. So we engage people around this issue right from the beginning. We explain to stakeholders why we do this research, how and what we want to contribute to the country processes. Then we go together into this co-designing of future pathways, multidisciplinary scientists along with multidisciplinary stakeholders at the national level and at the provincial or subnational level in a particular context. In this case, we illustrate business as usual hasn't worked, doesn't lift many people out of poverty. We need to go more out of the box, as John said. Green or gray pathways. For those futures, we define then with the stakeholders adaptation packages. In this particular case, stakeholders said, again, no, we want to first understand what can we do in the next 5 years because our productivity is so low that we are not even interested in the future. So we incorporated that as well. Then we realized if we go along these future pathways, climate change adaptation would actually be very easy because in this case, they said it would just be a switch in varieties, better crops, more heat tolerant and drought tolerant crop varieties, because we have done already so much towards that future. From there, we would then do our impact assessments and share this with stakeholders and discuss together. So what does it mean? How can we use it in the country in our current situation? Here's some examples as simple as we then develop them with stakeholders so that they portray simple messages. Stakeholders said the priority is for the near term and a simple 3-step approach was suggested in also collaboration with farming communities, which created a lot of legitimacy. So these 3 steps were basically improving cereal production through improved management. I'm not going into details. With that production, reducing the land from cereals into legumes, which are more profitable, grain and forage legumes, and 3, creating market incentives, believing that there is an institutional network there, but not fully utilized, and we could double prices for quality legumes within the very near future. The result shows simply that from ABSIM and DSAT simulations that under those low soil fertility conditions, if we improve management, the potential uptake response is high. So maize cereal yields increased by 100% is very possible. 200% increase in groundnut yields is also very possible because as orphan crops, they have been so much neglected. Then feeding the residues from this crop improvement into livestock would increase offtake by 15%, which is huge, and milk yields by 30%. Converting this now into net return analysis shows us that for each of the step and for each farm type, like extremely poor farmers with no livestock, then so with small herd sizes and large herd sizes, shows that adoption rates would be very high, 70 to 90%. So this is an attractive option for most farmers. We furthermore see that the net returns for the extremely poor triple. The net returns for those with larger herd sizes, they would increase by about 50 to 100%. Of course, those with large herd sizes in absolute terms would gain more. And this is another critical point to say we need inclusive market-oriented development because those with big herds can supply more reliably good quality products to markets to which then the extremely poor can also supply when they need it. We, from here, moved into the future, created these different pathways. Stakeholders have indigenous names for these pathways now. Green Zimbabwe, inclusive market-oriented development, everybody would set more land in value. Everybody would expand the legumes and improve soil fertility management and keep more and more productive livestock and sell more livestock. On the other side, the fast economic growth reminded people on the past in Southern Africa. Few people have a lot of land and a lot of livestock. They depend largely on external resources, and many people are driven by food security needs and work a lot off farm to subsidize their income. As I said before, adaptation packages here would be a switch in crop varieties. A short overview on how we would present these results then to stakeholders, generated with stakeholders. You see on the top left box, climate change projections. We believe that the temperatures will be drier and there's more uncertainty about rainfall pattern. Under those climatic conditions, we believe also that crops respond differently. Cereals being more sensitive to these climate change effects, whereas legumes are less sensitive, so more climate resilient. The highlight here was that livestock would be very sensitive to climate change because of the effects on rangelands. This was something that nobody would expect at that moment in time. If we convert then into the vulnerability assessment at the lower left box, yellow, we could see that the gray, under the gray pathway, more people would be vulnerable to climate change, and in particular those with large herd sizes, because they would face a far greater risk of losing their animals under climate change, depending on external resources. On the other side, when it comes to climate change adaptation, the green pathway was easier to adopt, and especially those households with no livestock would benefit relatively more. It means we can sell green pathways as less risky and easier to adopt for poor households. We would tell policymakers that, look, you can reduce poverty more effectively if you follow the green road. And there's a positive correlation between market incentives, farm diversification, women, gender empowerment, and nutrition and food security. So we believe these are the type of powerful policy messages which create the dialogue with stakeholders. Having this in mind, what are the outcomes after 4 years of AgMIP CLIP in Zimbabwe? We believe, number one, the relationship between science and policy making has really improved. And this co-designing messages together was a critical element. These stakeholders, they take the messages by themselves further into their respective working environments. Without that, we push this, but there's a greater confidence in these type of results. We can now assess global drivers in local context and discuss that with stakeholders as well. And we feel we have really bridged this knowledge and have discussed issues at local to national scales, as well as the different time horizons to make people closer thinking about how to operationalize solutions. Then this joint design of the interventions have caused the government to ask us as researchers contributing to their national climate change adaptation programs. reason why we then did national scenario development. So there's really a demand by stakeholders now for research, which wasn't the case much before. All in all, we have greater credibility, having the AgMIP network in the back. Legitimacy, because all these adaptations were tested and discussed with communities as well. Confidence in the green pathway, and ownership. As I said, there's indigenous names for the scenarios now. But what is still missing if we want to work towards transformation? We believe that there need to be better mechanisms for real tangible outcomes like nutrition, conflicts. So the research protocol is really responding to these policy requirements. We also need greater continuity of feedback verification of these impact assessments. Yeah, we believe also we didn't have the time to really develop the structures influencing the national system. So there is something to come. And we also haven't worked enough with the regional bodies, which would be very helpful, like CCAPS has done with Eastern and Western Africa on regional assessments. And in Southern Africa, this is not available, but could be a huge momentum to create urgency. What else? I would like to challenge you and look at our challenge in terms of this iceberg, where we need to recognize that whatever we want to do, there are things that are visible above the ice, above the water, and their issues are not visible to us as scientists or as policymakers. So in this term, we can say understanding the multidimensional impacts that which AgMIP does help us is like characterizing the landscape. Doing the stakeholder engagement is digging deeper, getting into the influential structures of decision processes. But how can we use these next generation programs to really address the issues that are burning, which is nutrition, conflicts around biomass. Imagine people want to keep more animals by 2050, and consumers are asking for more livestock products, as well as the issue of equitable benefit sharing safety nets. Large proportion of the population cannot be moved out of poverty. That's a fact, I believe. On the other side, when it comes to policy decision-making, again, far more is underwater for us because these processes are not very transparent often. It's a lot about politics, it's about power and relationships, stakeholders or themselves not having a clear direction, not even knowing how to demand what they want from scientists, and also facing all these challenges of different ministries working in different directions. But we feel we have started a dialogue and we have gained a lot of momentum in moving forward on how we can influence these processes. And above all, and the deepest, the change in mindset amongst everybody. We always talk about change in mindset of farmers. We think there's a change in mindset of scientists and as well as in policymakers. I'm not going to go deeper, but maybe one point to say, like, if we would enlighten people, or what are the real issues of poverty, and if we would share it and discuss it, so what would it provoke and what responses could we bring forward? So how then, my last points, can we help to upscale science to support decision-making processes? Here we feel, yeah, if we want to work on transformation, we need a broader set of indicators, not only production and productivity, but the whole range of food systems. We need to use that information to synchronize food demand and supply side, that particular for the case of Southern Africa, which is so dominated by maize and which can be diversified and become healthier. We need more experimental learning between research and policymaking, and we need to develop really roadmaps with policymakers on how can we help them to achieve what they want within the institutions that are there. This means that we need to change our research approaches probably towards more integrated. We're doing already integrated assessment, but can we be integrated, simplified, and use this protocol-based approaches for particular issues? And also on the funding side, then long-term funding, research programs, and alliances. I know I'm dreaming, that's why it's blue. With this in mind, just some images on, we feel we have influence in Southern Africa, in Zimbabwe in particular. Imagine there is no forage seed in the country available for sale for farmers who would like to feed their livestock better. We have provoked the decision that forage production is now part on the drought mitigation program. There is now seed multiplication on irrigation schemes, which was impossible before. It was all for food production. We have sensitized far more about the importance of legumes, not only for food and soil, but also in terms of climate resilience. and the small grains, which we would like to blend in with safer maize for a staple food in these sites. Thank you.
So thanks very much, Sabina. Very impressive, I think. And if you agree, I mean, this was a wonderful range from the technicalities of crop model ensembles down to, you know, what happens in one of the regional analysis. And remember, I mean, there are several other regions, right? I mean, this breadth of knowledge base we have now, and also that we have really shown that we can do it. I mean, 5-6 years ago, we were talking about the planning of this coordinated assessment, and here are the results. Really fantastic, I think. So now you have listened a lot. That has been nice and interesting for you, I hope. Now the work part of the workshop starts. So I was told Eric has sent around this one slide for reporting back from the session. So we would ask all the session chairs, not only from the working sessions, also from the parallel sessions, to give a brief summary and hand it back to Eric, I guess, no, to the info@agmip.org address so that we can collect them. And thanks again for the 4 presenters also to sticking within their time. So thank you.
Herman, for the report backs, I think the parallel sessions, it's okay, we don't need to do that. We haven't set up rapporteurs. Of course, if anyone would like to, that we're happy to do them. The report backs in particular are for the working sessions, which start at 3:50. And the report backs will be, all of those are meeting both today and on Thursday. So those report backs, you know, keep your notes and to start developing your report back, because the report backs will be given on Thursday in the afternoon. Thanks.
Good, thank you. So now we go all for lunch over to the cafeteria, and then the parallel sessions will be in the opposite building where there are 5 parallel rooms. So thank you very much for your attention.